Thank you, the choir, for such a beautiful performance. Ladies and gentlemen, to begin this event with the blessings, I would like to invite Mr. Khairul Umam, SHMH, to lead the dua recitation for Muslim and a moment of silence. To Mr. Umam, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Let us bow our head for a moment, pray to God, Allah subhanahu wa ta'ala, so that our international conference can be precious to all of us. I will lead this prayer based on teaching of Islam, and those who are not Muslim, you are pleased to pray according to each of your beliefs. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم ارزقنا فهم النبيين وحفظ المرسلين وإلحام الملائكة المقربين برحمتك يا أرحم الراحمين. اللهم اجعل جمعنا هذا جمعا مرحوما وتفرقنا من بعده تفرقا معصوما. Oh Allah, today we gather here to bring about an international conference on bioscience and biotechnology. Make this international conference as a useful science assembly, as a medium of sharing useful ideas, knowledge, and experience of scholars, researchers, and students of various disciplines. May the conference we organize today benefit to our lives, broaden our knowledge, shine our ideas, and lead us to be successful, productive person, which in turn will boast dignity of our nation. O Allah, guide and bless our hearts and our minds with the light of your guidance. Impart your supreme wisdom upon our activities. Help us to speak our minds clearly. Help us to listen to each other, respect each other's, love each other's, so that we are included to blessed person. O Allah, protect us from unintended temptation, show us the right path, and give us knowledge and strength to perform good things equally. Show us and make it clear the bad things, and give us knowledge and strength to avoid them. O Allah, you are the one who can fulfill our dua. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. السلام عليكم ورحمة الله وبركاته.
Thank you, Mr. Umang, for leading the dua recitation. Excellencies, our distinguished guests, ladies and gentlemen, without further ado, it is now my deep pleasure to invite the Vice Rector of University of Mataram for delivering an opening speech. Please welcome Dr. Agustin SE, MBA, DBA. To Dr. Agustin, time is yours.
To all distinguished speakers, chairman of this conference, Ekas Narwidi Prastia PhD, all my colleagues at the University of Mataram, all participants of this conference, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh. Good morning. First of all, let us thank Allah, the God Almighty, for blessing and guiding us into the right path and for granting all means and opportunities to be here to attend these very meaningful occasions. To all participants of this conference, it is a great pleasure and an honor for me to deliver this welcoming remark at the opening ceremony of the 5th International Conference on Bioscience and Biotechnology 2022 with the theme Current Challenges on Sustainable Utilizations of Marine Resources. This year's conference is a continuing the successful of the previous year conference in order to facilitate scientists, researchers, and interested observers to be involved actively in the progress of biotechnology and biological sciences. It is also in accordance with the vision of University of Mataram to become a research-based international competitive university by the year 2025. This international conference is one among many efforts to make these visions come true. In the current situations of post-pandemic, we are facing challenges, especially those related to health, education, and technology issues. We must address the sustainability agenda to deliver improvements to meet these challenges. Today, with the public and private sectors, non-governmental and intergovernmental organizations, scientists, engineers, medical doctors, professionals in social science studies, such as law, business, and policymakers must work and discuss together on the application of knowledge and science and technology to help us to cope with these issues and problems. Ladies and gentlemen, the World Bank defines blue economy as a sustainable use of ocean resources for economic growth, improved livelihoods, and job while preserving the health of ocean ecosystem. Blue economy holds the key to Indonesian sustainable prosperity. It encompasses many activities such as fisheries, renewable energy, tourism, maritime transport, waste management, and climate change mitigations. When this managed sustainably, each and every sector can contribute to Indonesian prosperity. There are several staggering facts about Indonesia's marine and fisheries richness. The archipelago nation is second only to China as the world's largest fishing nation. Its ocean is also a large part of the Coral Triangle area, where 76% of the world coral species and 37% of the world coral reef species lives. As the largest university in the province, with more than 34,000 students, more than 1,100 lecturers and professors, consisting of 9 faculties and 66 study programs, the University of Mataram has always been at the forefront of contributing to the efforts of improving the quality of life of the people of this province and Indonesia in general. We look forward to increasing our collaboration with government agencies, industries, and other partners to further strengthen and implement regional development goals and a sustainable ocean economy. On behalf of University of Mataram, I would like to extend our gratitude, especially to all keynote speakers. Professor Lim Paik M, PhD from University of Malaya, Malaysia. Professor Michael U. Roleda, PhD from the University of Philippines. Professor Delin Duan, PhD from Institute of Oceanology, Chinese Academy of Science. Associate Professor Yasuhiro Kato, PhD from Keio University Global Research Institute, Japan. Munawar Halil, PhD from University of Indonesia. Victor Nikijulu, PhD from Yayasan Konservasi Cakrawala, Indonesia. And Cahya Kurnia Pusianto, PhD from Michigan State University, USA. And Bapak Dr. Ateng Supriyatna, MSc, Fisheries and Aquaculture Program Manager, Yayasan Konservasi Indonesia. My great appreciation also to all participants and all committee members of this conference. And I hope this conference can produce papers that will be published in reputable national and international journals and recommendation related to efforts to overcome and find solution to the problem faced by our government and communities and different countries such as Indonesia. Finally, with Bismillahirrahmanirrahim, I officially open the 5th International Conference on Bioscience and Biotechnology with the theme Current Challenges on Sustainable Utilization of Marine Resources. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Agustin, for the opening speech. Excellencies, ladies and gentlemen, for our next agenda, I would like to invite the chairman of ICBB 2022 to deliver an opening speech. Please welcome Dr. Eka Sunarwidi Prasedia. To Dr. Eka, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Your Excellencies, the Vice President in Academics of University of Mataram, Dr. Agustin, thank you for representing Prof. Bambang Engineer Harikusumo as the Rector of University of Mataram, which could not attend our meeting today because he is currently in Italy for establishing an MOU in foreign affairs. Also, I would like to welcome Your Excellencies, the Dean of Mathematics and Natural Sciences Faculty, Prof. Dedi Sudehendra, and Vice Deans of Mathematics and Natural Sciences Faculty, the Head of Postgraduate Studies, Professor Muhammad Sarjan, the representative from Director of Research and Development Center, Prof. Buan Ansari, and also Prof. Dahlan from International Office Affairs. And I would like to also thank you, the distinguished invitations I sent to fellow researchers and scientists from University of Mataram, and also distinguished guests from governmental agencies, the National Agency for Research and Innovation, Badan Riset dan Inovasi Nasional, BRIN, and West Nusa Tenggara Region Agency for Marine Affairs and Fisheries, West Nusa Tenggara Region Agency for Environmental and Forestry, and the Lombok Central Region for Fisheries and Aquaculture. I hope that I would like to thank you for attending the ICBB meeting today, whether either offline and online. And I would hope that our meeting today, we could produce some great ideas and for future collaboration research, and hopefully increase the quality of our research outputs. And on behalf of the ICBB 2022 committee, I would like to thank all the presenters and speakers who have submitted their valuable work. And I am also looking forward to the discussions which will be held tomorrow on the panel session on Friday and 7th October. And all the audiences joining online, I hope you will stay tuned until our keynote session 1 and either the second keynote session, which will be held after lunch and 13 to 15 West Central Indonesian time. I would also like to express my deepest gratitude to the honorable keynote speakers who have accepted our invitation to share their current work, the valuable and cutting-edge research, which hopefully would bridge our network collaboration between us universities here in Indonesia and research institutions here in Indonesia, and further become much more closer to reaching our main goal for achieving the blue economy. So the 5th ICBB 2022, in this year's conference, we choose to focus on the current challenges on sustainable utilization of marine resources. And by doing so, we were lucky to receive supporting funding from the Indonesian Ministry of Education, Culture, Research and Technology, and to support the G20 presidency initiative in which is held in Indonesia by this year in 2022. And I would like to explain why we choose this and why it is important to focus on this theme. So when we look into, when we see Indonesia also as the country which is mostly covered in the ocean, it holds a tremendous potential to spur economic growth, which later on, this will then create jobs and mitigate some of the most severe climate change impacts. But there's a big if we want to achieve this goal, we have to protect it and we have to consider some guidelines to use these resources sustainably. And this initiative goal is often referred as the blue economy. So the G20 members comprises, including Indonesia, these countries comprises more than 45% of the world's coastline and nearly 21% of the economic exclusive zones. This makes that these countries are specially obligated to protect their marine ecosystems. And also, it is actually in a very good position if these countries would consider to develop a policy, a marine-based policy for the economy rebuilding, especially in this economy rebuilding era, past or post-pandemic era. So in order to achieve the blue economy, I would like to address some certain areas that we could focus on, and hopefully in the future would collaborate together. And that's why by this occasion, I am happy to introduce some of the keynote speakers joining us today. First is Professor Lim Pek Im. So Professor Lim Pek Im usually attends ICBB 2022, but the last time Professor Lim came to Lombok was, I think, in 2019 on the second ICBB 2022. So I hope Professor Lim could come in probably next year to collaborate again in Lombok. Also, she is the Deputy Director of the IUES Department, Institute of Ocean and Earth Sciences from University of Malaya. The University of Malaya is the top university in Malaysia and is actually ranked in the QS 100 Global University Rankings. And also we have Professor Delin Duan. Professor Delin Duan is the leading professor in a prestigious university in China, the Institute of Oceanology, the Chinese Academy of Science. And recently he offered collaboration with us, University of Malaya, Mataram, to further develop co-supervising students and master students and PhD. And actually, Prof. Delin Duan was also a visiting professor once in Harvard and also Stanford University. And we also have Dr. Victor Nikijulu. He is the Senior Director from Conservation International Indonesia. And he was actually a former Director General for the fisheries, marketing and processes for the Indonesian Ministry of Marine Affairs and Fisheries. But unfortunately today, Pak Victor, due to health issues, cannot attend our meeting. That's why he is represented by his co-worker, Pak Dr. Ateng Supriyatna. He is the program manager for aquaculture, for working together with Pak Dr. Victor in Conservation International Indonesia. And for session 2, we also have very interesting speakers. We have Dr. Munawar Halil. He is a leading scientist in Indonesia, actually, for nanomaterials and nanotechnology. And currently, he is the Director of Research and Development in University of Indonesia. And we have Dr. Cahya Kurnia Fusianto. He is a researcher in Michigan State University, and he is working on fish viral diseases in aquaculture and biosecurity systems. And then we have Dr. Kim Lee Chang, CSIRO Australia. He will share some of his work in CSIRO in developing macroalgae for sustainable use. And lastly, we will have Professor Kato Yasuhiro from Keio University, Japan, which is located in Tokyo. He will share some of his work on applying omics for sustainable use of marine resources. Unfortunately, for the last speaker, Professor Mikey Roleda from the University of Philippines could not join us today due to some work that he has to finish. But his students will present tomorrow in the panel session. So if you are interested in knowing what Professor Mikey is working on, you can join the panel session in the aquaculture section on the panel section tomorrow in Friday. So for the areas I would like to address that we probably merge our ideas together is to achieve the blue economy. So first, I think the maritime resource holds a very tremendous potential for renewable bioenergy sources. So I think some of the authors already submitted their papers and their work on developing bioenergy sources from marine organisms. And actually there has been a tremendous amount of evidence which shows that marine organisms could actually provide potential biofuel and biodiesel for future energy potential. And the second is marine sources as bioactive compounds. And this is one area which I am also very concerned in, because the ocean actually covers more than 60%, 67% actually, of the global area. And it is very interesting ecosystem to develop and to be explored for vast biodiversity of various molecules, which then could be end process to end products and develop into fast growing industries, especially like food and agriculture industries and pharmaceutical industries. And the third one is the coastal wetlands and ecosystems. This is also an interesting area, as some of the marine ecosystems, such as salt marshes and seagrass and seaweed farms, seaweed grass and seaweed meadows, coral reefs, and mangrove forests. These marine ecosystems, they need urgent protection because they play a crucial role in critical environmental functions and structure. That to put this into perspective, these marine ecosystems, they sequester more than 5 times more carbon compared to terrestrial forests. And while doing so, they could create a coastal, shielding coastal populations from increasingly climate damaging impacts, such as powerful storms, sea level rise, and currently the increase of UV radiation. And of course, another area is investing in sustainable fisheries. So high advanced aquaculture technologies we should learn from other countries, Asian countries such as Philippines and Malaysia are also in China are already developing advanced aquaculture systems. This could create well-paid jobs and help promote food security and economic fairness, especially in developing countries, which mostly are surrounded by coastal areas. And the last area of interest is with this area is actually where Indonesia could really thrive, is sustainable and regenerative tourism. This can form a critical building block in ensuring a lasting economic recovery in a way that it does not only increase the economic of the region, but while doing so, it could also support the ocean and the nature. So by considering investing in these areas, we hope that it is very promising to create or to become closer to the blue economy driven nation, and in the long run could eventually eventually achieve the UN sustainable goal, the UN SDGs goal number 14, which is life below water, conserve and sustainably use of the oceans, seas, and marine resources. That's why as this year's G20 presidency, I believe that universities in Indonesia, especially University of Mataram, which is located in Lombok Island, where we are surrounded by coastal areas, we should make major investments and turn our focus much more in investing in the marine and coastal ecosystem governance, promising equal economy access, reducing marine debris, and working to restore and conserve mangrove and other critical marine ecosystem areas which I just mentioned before. So the universities in Indonesia and the University of Mataram especially must expand these efforts and of course increase collaboration and hold hand by hand, not only with researchers and staff from universities, but also we have to collaborate with our fellow scientists from research institutions such as Badan Inovasi dan Riset Nasional, BRIN, and also governmental policymakers and also industrial players. Only then we could further strengthen and implement a robust and sustainable global blue economy that could hopefully beneficial for everyone. Thank you very much. That's all my speech for today. I wish you have a very great conference today, and hopefully we can, the output is not only publication of the article submitted, but we could build a research proposal together, or maybe plan some research together for the future. So I hope we can make more science after this meeting. I hope you have a very good conference. Thank you very much for attending the opening ceremony for ICBB 2022. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Eka, for the speech. Excellencies, ladies and gentlemen, before we come to our main agenda for today's conference, which is a plenary session we are holding photo sessions. All guests of honor are welcome to take a position on the stage. Please. And of course, I would like to invite participants in this conference to take a position in front of the stage. Everyone is welcome. All participants, you are welcome to take a position in front of the stage. And for all keynote speakers who attend this conference through Zoom meeting, please turn on your camera and give your best smile. Once again, to all keynote speakers who attend this conference through Zoom meeting, please turn on your camera. And everyone, please give your best smile. Thank you. One, two, three. Mr. Eka, please have the position. One, two, three. Freestyle. Unram Jaya. For the second session of conversation, I would like to invite all the committee members to take a position in front of the stage with the guests of honors. All the committee members, please take a position with the guests of honors. Okay, once again, please, with all committee members, please take a position in front of the stage. We are going to have a photo session. Mari Bapak-Bapak, Ibu-Ibu, Komite Panitia ICBB. Silakan. Thank you very much, everyone. And please have your seat. Ladies and gentlemen, before moving to the plenary session, let's close this ceremony by saying Alhamdulillah. And I would like to inform everyone that all participants are welcome to have and enjoy the dishes that we have served. Silakan untuk bapak-bapak dan ibu-ibu para tamu partisipan, kami sudah menyediakan coffee dan beberapa dish di luar ruangan. So everyone of you is welcome to enjoy the dishes. Excellencies, ladies and gentlemen, those are the agendas we have this morning. As we have finished our opening ceremony, coming up to the next session, we are going to have a plenary session. So I would like to invite all the participants to come back to your position since we are going to start the plenary session. Thank you. Untuk para partisipan, untuk para partisipan, sebentar lagi kita akan mulai plenary session. Silakan untuk mengambil posisi kembali. Ladies and gentlemen, for the first plenary session, I would like to invite our moderator, Dr. Eka Prasadia. Excuse me. I would like to invite Dr. Aluh Nikmatullah, Associate Professor of Agro-Ecotechnology Study Program, Faculty of Agriculture, University of Mataram. And also, I would like to invite our keynote speakers, Professor Limpek Im, Professor Delin Duan, and Dr. Victor Nikijulu. Sekali lagi, kami mengundang seluruh partisipan untuk kembali ke ruangan, karena sesaat lagi kita akan memulai plenary session. And for this session, I would like to invite Dr. Insinyur Aluh Nikmatullah to the stage. Untuk seluruh partisipan, kami mohon kesediaannya untuk kembali ke ruangan sambil menikmati dessert yang sudah kami sediakan. I would like to invite Professor Buan Ansari, the Head of Public Relations and Collaboration from the Department of Research Development, Faculty of Engineering. I would like to invite Professor Buan Ansari to the stage. And for all participants, please enter the meeting room since we have to start the plenary session. Thank you. Tes online, tes yang di Zoom. I would like to invite Professor Buan Ansari to the stage. Once again, I would like to invite Professor Buan Ansari, the Head of Public Relations and Collaboration from Department of Research Development, Faculty of Engineering. Tes. Zoom. Okay, thank you.
Good morning, ladies and gentlemen. Before we start, I would like to check again that all of our keynote speakers are already present. Good morning, problem 5 in. Problem, are you here with us? Morning, problem.
Good morning.
Morning, problem is. Good morning, problem.
Yeah, good morning, Dr. Alok. Just now I was not able to unmute. Yeah, now I'm unmute already.
Nice to meet you.
Nice to meet all of you.
Again, Prof. Yes, thank you for coming. And I would like also to say good morning to Prof. Delin Duan. Are you here with us, Prof. Delin Duan?
Sorry. It's okay now.
Good morning, Prof.
Can you hear me?
Well, nice to meet you. Thank you very much. And the third speaker is Dr. Victor Diki Juru, which will be represented by Dr. Ateng. Good morning, Pak Victor.
Yeah, I'm here. Good morning. Greetings from Jakarta.
Thank you very much to be present. And are you going to present the paper or will be represented by Pak Atang today?
I can present the paper, but later on, if there is a comment question regarding my presentation, can be entertained by Pak Ateng. So I'll take it first, and later on in the discussion, Pak Ateng will represent me.
Thank you very much. So I think our connection is very good. Yes, I can hear very clearly all of our speakers and also the participants, because this conference is in hybrid form. So we better start, I think, the conference. Good morning, ladies and gentlemen. Here with me in the front is Dr. Eka Prasetya and Professor Buan Ansari from University of Makassar. Prof. Buan Ansari is a lecturer in Department of Civil Engineering, Faculty of Engineering, University of Mataram. He graduated from Mataram University in 1997 for his bachelor degree, then conducted a master degree in the University of Liverpool and got the MSc Engineering in 2001. In 2013, he finished his PhD from 2021 to 2013, PhD in University of Liverpool, UK as well. Thank you for coming, accompanying me here this morning. So, ladies and gentlemen, first of all, I would like to welcome you all to this plenary session 1 of the 5th International Conference on Bioscience and Biotechnology. Today, Thursday, 6th of October, 2022. Thanks to the committee, my name is Alung Nikmatullah from Faculty of Agriculture, University of Mataram. Welcome, Pak Ateng. So, my name is Alung Nikmatullah from Faculty of Agriculture, University of Mataram, and it is a great honor for me to chair this very important session. We will have 3 presenters in this session. So the first presenter is Professor Lim Pai Kim, PhD, from Institute of Ocean and Earth Sciences, University of Malaya. Second presenter, Prof. Delin Duan. He's a principal investigator from Institute of Oceanology, Chinese Academy of Sciences. Third presenter, Dr. Victor Nikichulo, Senior Director Conservation International Indonesia. Without further delay, we will soon start the presentation from all of our keynote speakers. For audiences, online audiences, while the keynote speaker presenting, you could send a question in the chat box, or later on, I will invite online participant, but please turn on the raise hand button. Yeah? And there will be also opportunity for our live participant, for our participant here, to later on send a question to our keynote speaker. Ladies and gentlemen, we should start with our first keynote speaker, Professor Dr. Lim Pai Kim. Professor Dr. Lim Pai Kim is the professor and deputy director of Institute of Ocean and Earth Sciences, University of Malaya in Malaysia. She is one of the founder member and the current secretary of the consortium of Southeast Asia Seaweed Taxonomy. She has more than 20-year experience doing research with seaweed, very long research with seaweed, and she has a lot of experience. And Dr. Eka was one of his students. Yeah? He's a student during Dr. Eka master degree in Malaysia. Prof. Lim Pai Kim has published more than 180 publications. He is very productive. And with the challenges facing in the kerajinan industry, especially lack of present, especially lack of genetic diversity in this eukaryote species, she has been working with genetic diversity of this eukaryote. There's also collaboration between Malaya University and University of Mataram, working with this genetic diversity of eukaryote. So, without further delay, I think I will invite Prof. Lim to give her presentation. Prof, your time for presentation is about 25 minutes. Time is your, Prof.
Okay, a very good morning to all of you. Can you all hear me well? Okay, first of all, I would like to thank Dr. Allah for a very kind introduction, and also the organizing committee of ICBB 2022 for inviting me to share with you the topic on sustainability of eukaryote aquaculture facing climate change. Okay, I would like to introduce, we know that seafood, both fisheries, shell, as well as seaweeds are important resources, which traditional, they are obtained through wall catch or wall harvesting. However, due to the continuous increase of world population, the demand for food resources increase, and aquaculture have been introduced to cater the needs. Okay, let us look into as regards about the world fishery production trend. In the past, most of the production are through war catch. However, through today, we can see that the aquaculture has surpassed the war catch, especially that I would like to highlight that for algae, as today, there are 97% have been catered through aquaculture. This is the trend of the main producer of the world algae. We know that China is the largest producer, followed with Indonesia, Republic of Korea, and Philippines. If we look into as regards about the geography position and as well as availability of the ocean, we know that Indonesia and the Southeast Asia country will be upcoming large producer due to the availability of the large sea area. Okay, this is the trend showing you about the world production of various sectors. In general, we can see all the various sectors, there's an increase of production, and the same thing for algae as well. Algae is the one that's highlighted in green color. The overall production have been increased since 1992 till 2020. However, based on the data for the production in year 2020, despite of that, the world production is increased, but the production in Southeast Asia country have declined. Thus, there's a need for us to look into what are the potential causes that cause the decline in terms of production. Okay, now let us look into as per scenario in Malaysia. This is the seaweed production as well as value from 2006 to 2020. As you can see from the graph, actually since the establishment of the seaweed aquaculture in Malaysia, which actually started in the late 1970s, the production have been slowly increased until 2012. However, after we reached the peak in 2012, we experienced the production decline. And what are the potential causes that cause the decline is something that is important in order for us to sustain the aquaculture industry in Malaysia. Okay, based on our study, there are various issues and challenges that are facing by our seaweed aquaculture. One of it are climate change, cultivar, as regards about the low genetic diversity, as well as shortage of cultivar. Then we do have some security issue, and then shortage of labor, price instability, and then also value change that solely depend on carcinogen. In order to allow higher income, there's a need to diversify as regards about product that can be produced from seaweeds. And also there's a need to look into to provide more effective aquaculture practice. As for today, I will highlight the issue mainly on climate change in my today talk. Okay, now let us look into the global scenario as regards about our environment. We have heard many people say climate change is here, and let us look into the data. The availability of current data is actually also supporting that, showing we are actually in the midst of climate change, and based on the scientific data, we can see we have experienced increase of temperature like never before. And if there's no mitigation being take place, I think the severity will be continue. So, and then due to the global warming, the ocean also is not running away, in which the ocean also experience ocean heats. And if you look into the trend, they are increasing. And this is the publication by the guiding showing that global heating actually pushes tropical regions toward limit of human liability. We know that climate change have great impact, not only to human, okay, but to many other organisms, but we know that it will also impact the food resources, such as agriculture, as well as aquaculture, and aquaculture of seaweed also cannot escape from this impact. Okay, and based on the data, actually it shows that global warming is official, and 2021 was the world 6th warmest year on record. So it seems like we are toward and reaching. It seems that each year are recording the highest warmest year of record. Okay, besides global warming, another challenges that facing the ocean is ocean acidification. It is actually referred to a reduction of the pH of the ocean over an extended period of time. And this is primarily caused by the uptake of CO2 from the atmosphere. And we know that CO2 emission have been increased due to the industrialized. Okay, this is the graph showing you the carbon dioxide level. And we have seen that actually at the current level, it is actually much higher compared to back to trace to more than 800 years ago. So, and we know that this climate change have caused extreme events that happen and take place more frequently. We are seeing and experiencing more severe drought, extreme participation event, coastal flooding, as well as heat waves. All this uncertainty will bring impact to the agriculture as well as aquaculture. Okay. However, if we look into compared to the agriculture of the land plants, in comparison to aquaculture of seaweeds, we do have limitation in terms of our understanding and how will climate change impact our crops. So with that, our group have initiated the study on the physiobiochemical responses of Kappa ficus avrasea and Kappa ficus striatus to elevated temperature. The choice of these two species is mainly, these are the two main euchymatoid species that is cultured for commercial worldwide among the main producer. Okay, we know that when we talk about euchymatoid, it's actually referring to a group of seaweed which is comprised of genera, Kappa ficus and euchyma that are cultivated in our region that is with the tropical or subtropical climate. And we know that the world's largest producer is actually mainly in the Coral Triangle, with the Indonesia with the largest producer, followed by Philippines and Malaysia. And Kappa ficus is the most prominent commercial source of carrageenan, which have a great economic value. Kappa ficus farming is actually a very important source of income, especially offer a means of livelihood to local community, as well as also for commercial production, especially in meeting the increasing industrial demand for carrageenan. Okay. However, due to the challenges due to acute warming, it actually have impact on the aquaculture of this industry. Okay, in the absence of concrete measure to mitigate climate change, extreme events such as heat wave, typhoon, El Nino, and La Nino are increasing that affect the seawater temperature. And because of the abrupt changes in temperature, Kappa ficus are prone to ice disease. Ice disease is the whitening that happened, and this will cause subsequently a significant decrease in terms of the seaweed production, which in turn it will reduce the growth rate as well as biomass, as well as decrease in carrageenan yield. It's also reduce the quality of the carrageenan in terms of the viscosity as well as gel strength. Okay, hence the main objective of our research is actually to identify among these two species, Kappa ficus and Avrassia and Kappa ficus striatus, which one can better with the elevated temperature, and the measurement is based on physio-biochemical aspect, where we measure the growth, photosynthesis performance, which will determine the health of the seaweed, as well as the quality or the biochemical aspect, such as pigment content, colloid, the yield, as well as quality, and as well as ROS production is to determine the state of stress that the seaweed were experiencing. Okay, this is the flowchart showing COD methodology that were carried out. For Malaysia, we actually only have one area that is cultivated the Kappa ficus and Eucheuma commercially, which is at the eastern part of Sabah, and the sample were collected from the field, and then we brought back to the laboratory, where we will firstly keep the seaweed as stock and maintain laboratory, and we will acclimatize them first before we start the project on, in which we induce elevated temperature. Below are the temperatures that the profile, the parameter that we use to store or keep our stock. And then in order to make sure the identity of the seaweed that we use are correct as we desire, we carry out the morphological as well as molecular identification, and in which molecular identification we are using the two molecular marker, which is called true 3 spacer as well as COX-1 spacer. And then for the physiological aspect of the study, we carry out growth rates, which we are based on fresh weight measurement, which is measured every 2 days. And then we look into the photosynthesis response, which is using PEM photometer. We also look into pigment content on the chlorophyll A, carotenoid, as well as phycobilirubin. And most of all, we know that Kappa ficus and Eucheuma is used to produce carrageenan. So the carrageenan quality test is very important, where we are looking into the yield, the gel viscosity, as well as gel strength. At the same time, we also carry out the reactive oxygen assay, and all the statistics were computed using statistical software. Sorry. Okay, so let us move into result. Okay, this is the growth rates of the two species. Okay, in general, the specific growth rate of both species decreased with increasing temperature above 28 degrees Celsius. Okay, the prolonged exposure to high temperature will lead to disruptive stress in the form of cellular and subcellular damage. And these damages may lead to slower grade according to previous publication. And this is proven through our study that with increasing temperature, the growth rate subsequently reduced. In comparing the two species, Kappa ficus Avrassia had better growth rate compared to Striatus, but there was no significant difference between the two species at temperature treatment of 28, 32, and 36 Celsius. Okay, let us look into the external morphology. What are the impact? So this is Kappa ficus Avrassia. I would like to highlight for 28 and 32, we can see in general, the species still can grow. However, when at 36 degrees Celsius, we start to see some whitening take place. And then for 40 degrees Celsius, I would say that the seaweed can barely survive, because at day 2, you can see all the plant turn white. As regards about Kappa ficus striatus, okay, for same phenomenon as shown in Kappa ficus ovrsia, at 28 and 32, they still grow well, okay. But how, as regard about for 36, they experience some whitening at daytime, but in terms of severity, Kappa ficus striatus is less compared to Kappa ficus ovrsia, but as 40 degree, it is all turning white as shown in Kappa ficus ovrsia as well. Okay, now let us look into the photosynthesis performance based on the FV-FM value. So in general, we can see that at the 28 and 32 degree, the series of fluctuates in between both 0.5 to 0.6 value of the FVM value, indicating they are at normal conditions and growing. However, based on the FVFM value, we can indicate that Kappa ficus striatus will much healthier and have better photosynthesis performance compared to Kappa ficus ovrsia at 28 and 32. Okay, and we know that high temperature has been proven also reduce the photosynthetic parameter by other study, and this indicate that there is a presence of a structural and functional disorder of photosynthetic apparatus and damage to the photosystem to have been taken place. Let us look into another parameter on the from the PEM reading, which is alpha. Alpha is actually to measure the efficiency of carbon fixation per unit light, in which in this study it shows that temperature at 36 and 40 notably inhibited the alpha, whereby the magnitude of inhibition increased with incubation of time. In general, Kappa ficus striatus were much healthier and have better photosynthetic performance compared to Kappa ficus ovrsia at 28 and 32. As for 36 and 40, we can see that these have experienced a severe reduction in terms of the alpha value. Okay, another PEM reading is the RET max, which is maximum relative electrons transport rate, show that actually the trend is similar as in FV-FM value as well as alpha value. So incubation at 36 and 40 degrees Celsius noticeably inhibited the RET max, whereby the magnitude of inhibition increased with incubation of time. No major difference were observed between Kappa ficus striatus and Kappa ficus ovrsia at 28 and 32 degrees Celsius. Okay, now let us look into in terms of the pigment contents. Okay, we know that the pigment content, especially picobilin, play a very important role in capturing light energy and transferring it to the chlorophyll during photosynthesis. And study that carried out by other researchers also supported our result. The picobilin protein, which in this study we measured the three main components, which is allophycocyanin, phycocyanin, and picoerythrin. It shows that it was highest in the strain incubated at 28 degrees Celsius, which is similar observation were observed by Arazo et al. For red and brown variant of Kappa ficus ovrsia. Okay, comparing the picobilin protein, Kappa ficus striatus has a high content for allophycocyanin and phycocyanin at both 28 and 32 compared to Kappa ficus ovrsia. But there was no significant in percentage mean inhibition between the temperature. Now let us look into in terms of the pigment content of chlorophyll A and carotenoid. I would say similar observation as picobilin, in which among all the temperature treatment, it showed the highest content at 28 degrees Celsius. Incubation beyond the ambient temperature 32, 36 and 40 start to introduce the reduction in terms of the pigment content. At temperature of 28 and 32, Kappa ficus striatus has better chlorophyll A and carotenoid pigment content compared to Kappa ficus aureusea, but there's no significant difference in terms of percentage of mean inhibition between the both temperature. Okay, so in general, and then now let us look into it in terms of the quality and quantity of the gel, of the carrageenan. Okay, temperature can affect the yield and quality of the carrageenan. So as observed in our present study, which shows that seaweed incubated at 32, 36, and 40% produce lower carrageenan yield in comparison to seaweed incubated at 28, which is the current temperature. And comparing the two species, Kappa ficus aureusea has a better carrageenan and gel strength at 28 degrees, but increasing temperature to 32 degrees Celsius, Kappa ficus striatus has better performance in those quality significantly. Gel viscosity between the two species show no significant difference at both temperature. So this shows that Kappa ficus aureusea at current rates, when we culture in the field, it will show better performance. But if the temperature increase, it seems like Kappa ficus striatus can perform better. So this shows Kappa ficus striatus could perform better at elevated temperature compared to Kappa ficus aureusea. So now let us look into as regards about the performance due to the ROS production. Okay, so comparing the two species. Okay, let me explain a bit. The production of reactive oxygen is caused mainly by stress, which is caused by inhibition of photosynthesis due to suboptimal conditions such as high light, UV, high or low temperature. When seaweed are exposed to high temperature, photoinhibition will occur, which lead to accumulation of reduced electron acceptor and may increase the generation of reactive radicals such as reactive oxygen, which can induce oxidative injury. The relative fluorescence will reduce to 5,000 to 600 after the first hour, indicating that the species are adapting to temperature. But overall, based on our study, it shows that comparing two species, Kappa ficus has higher DCF fluorescence compared to Kappa ficus aureusea for 48 hours, but there is no significant difference in mean value between the two species at the 4 temperature treatment. Okay, in conclusion from our study, the Kappa ficus species were able to grow in wide range of temperature, but stress was experienced or observed as above 32 and beyond. Temperature between 36 and 40 can be considered as upper temperature limit for the study strain. According to the result, Kappa ficus striatus could withstand higher temperature for longer day, display a higher FVFM value, higher carrageenan yield and pigment content compared to Kappa ficus aureusea. I would say that this result is rather preliminary. We need to understand more of what among more commercial strain, and we hope that this result can provide valuable information for farm management practices and to develop strategy to mitigate the effect of global warming. Okay, before I end my talk, I would like to pose these questions. Are the aquaculture of euchymatoids sustainable in the midst of climate change? Do we have knowledge as regards about the response due to climate change? I would say the current available knowledge is just the tip of the iceberg. That is very limited. So, and also at the same time, we need to identify the strain of species that are versatile to climate change, as well as pests and disease, for the sustainability of this aquaculture industry. Probably we can think of some of the strategy, such as probably cultivation technology that can possibly minimize the impact of climate change can be introduced. And we know that now we are living in a trend that's Internet of Things based on previous data that climate smart agriculture system actually have been studied. Probably climate change aquaculture is something that we can look into for aquaculture of eukaryotic. Despite of many challenges we are facing, but I think let us look at it positively. Challenges can be also opportunity for us. We can join our effort among the production country to come out to work together on research and strategy to help to safeguard the eukaryotic industry that is actually widely cultivated among us, with Indonesia is the leading producer and also main producer from other countries like Philippines and Malaysia also among the largest producers in the world. With that, I would like to end my talk by acknowledging all the different funding agencies for our study. And I would like to thank all of you for giving me the opportunity to share my research. Thank you.
Thank you very much, Prof. Lim, for managing the time very effectively. Before we continue to the next speaker, the committee would like to give a certificate of appreciation for Prof. Lim.
Thank you.
Yes, this is the certificate to Prof. Lim. Thank you, Prof. Lim.
Thank you.
So, ladies and gentlemen, we move to the next speaker, Professor Delin Duan. Professor Delin Duan, are you
Hello.
here? Yeah.
I just
Before we
tried
start-
to, yeah. I just tried to open my file and to co-share with all the audience now. Just wait a moment.
Okay, before Prof. Delin Duan start the presentation, I would like to briefly introduce Prof. Delin Duan. Prof. Delin Duan is Principal Investigator from Institute of Oceanology, Chinese Academy of Sciences. He obtained the PhD from the University of Chinese Academy of Sciences and finished postdoctoral in the University of Tokyo. And he was also the visiting professor in Harvard University and Stanford University. And Prof. Delin Duan currently is a foreign professor in the Hokkaido University and Tohoku University in Japan. So we are very lucky to get him today to give his expertise, to share his expertise to us. His research interest is in seaweed nursery and aquaculture, algal genetic and breeding, seaweed food, and functional component development. So far, he has published more than 100 scientific papers. So Prof. Delin Duan, time is yours.
Sorry, can you, it's really hard for me to share with my PPT. Just wait a moment. Sorry. Yeah. Can you hear this?
Yes, we can see and hear you very clearly, Prof.
Now it's okay for all the listener, yeah? Now I should start my presentation today. First, I should thank Dr. Ika for invitation for this meeting, and all thanks for the staff and students in University of Mataram in Indonesia. And today, my topic title is CVD extracts and its application in China. I will show mainly follow the four aspects from the backgrounds, main components, applications of CV products, and problem and perspectives existed. First, it could be introduced that seaweed production was less than 400 tons in China until last 50s, of which the Saccharina japonica only occupy 60 tons, and the Povera, including two species in China, occupy about 300. While in 1978, it reached about 20 million tons, of which the Saccharina japonica will reach to 17 million tons, and Povera reach 1.2 million tons. And all these productions occupy about 18% of the total agricultural production. I mean, seaweed agriculture is agriculture products. And from 1995 till 1920, they are about 6 times higher, and to the total seaweed production increase. In the 2005, the global seaweed production was about 1,816 million tons, while China produced 1,415 million tons. It occupy about 7,800, and it take about 19,500 in 2020. Looking back, the total estimation of world agriculture from different countries in Asia so far are the major producers, of which China, Indonesia, Republic of Korea, Philippines, and DPRK, or Japan, Malaysia, reach the second or third consequently. And in recent years, our countries actually talk about production, including Saccharina japonica and Gracilaria laminiformis in recent years. And Indonesia, I think the Incuma or Cabafica both state. Patently, the seaweed nursery and cultivation system were already established in our country, and the seed stock isolation and preservation system were either established. It persistently supported the seaweed industry on different levels and degrees. And so far, the seaweed cultivation values was about 45 billion US dollar, and the nursery value about 0.42 billion US dollar. These are to the brown seaweed. We are majorly on the Saccharina japonica, and recent years Costaria costata and other species. And one thing is needed to mention that in this 10 years, there are red algae we use and sexual reproduction, actually vegetative branch propagation measures. We widely cultivate these red algae Gracilaria laminiformis in both north and south areas in China, of which traditionally agriculture of Povera, we still keep that in Jiangsu and in Fujian province in different cultivation measures. However, in recent years, with the influence of science, in fact, of green ties, the local government and central government strictly prohibited the wild-scale cultivation of Papaya jasmine. That's made the local sea farmers had to move to Shandong province to continuously conduct this red algae. And however, the nursery was still kept in the local farms. While for the Undaria pinnata, we keep the certain amount of skill now in Shandong and in Liaoning province. And it's still out, we can limit the production skill for this brown seaweed. Another is we call Hydisia, is as a sargassum, I forget this terminology. It's actually very limited amount of production value, but the market needs are still in high in both China, Korea, and Japan. This was another glaciaria species were cultivated in the Fujian and Guangdong province. It's originally introduced from Taiwan, and we call it Glaciaria inchinoides. But the scale was very limited, even though the growth tendency was uprising now. And in these 2 years, at least 10 years, the green tides were occurred tremendously in every year from spring till the early of summer. And both the local government and the central government enhanced the monitoring degree and check either to enhance the utilization of these massive occurrences of the green tide. Actually, now it was, we have adapted a very good strategies for how to use this as a fertilizer for different levels. Another we call brown tides, actually is Sargassum zamburgai. It's caused many side effects to the local sea farmers for the popular cultivation. Almost each year, this brown tide occurred, and it caused side influence in both coastal areas in China, also to Jeju Islands in Korea. And so far, both two countries had to establish one system and strategies on how to cope with these brown tide occurrences. Now back to the seaweed industry. Usually for the seaweed industry, we implement many works on the seaweed cultivation and use the cultivate seaweed as food and either as used as chemical industry. However, in recent years, we conducted intensive work on seaweed extracts and the application in households or maybe high valuable products used as marine drugs. In addition, the low value, undeveloped or lower degree development seaweed extracts were used for agriculture applications such as the fertilizer and other aspects. And now some research agencies and universities still conduct works on some products development and try to apply seaweed in other fields such as seaweed textile used for clothes, for whatever, because it's have properties for antibacterial and for the self-fire, etc. Well, for the whole seaweed, actually, for ecological value, we should conduct the arginate, carrageen, and agar extraction and production and so far we manufacture about 35,000 tons a year, and which occupy at least 60% of the world total production. However, through the arginate for carrageen production, it's about 18 million tons a year, and for agar, it's about 12 million tons a year. For the rest of the two red agar production, I mean the carrageen and agar, I did not conduct any estimation for the contribution to the world total production. And for the values change, we initially use these seaweeds for textile, the dyeing agents, for foods as dye, for fertilizers, for cropland. And either in this year, we conduct many works on functional foods and cosmetics, and for biomedical materials such as trout, as skin, and for insertion materials for surgery. And finally, it was used for marine drugs. And so far, there are only 2 marine drugs which development from the seaweed in China. This was formerly the PSS, we just brave call it. It was developed in the 20 years ago. For the main components, we extracted and analyzed some seaweed main components from proteins, fatty acids, polysaccharide acids from the Saccharinella japonica, Porphyra hatinensis, Andaria pinophytata, cytophenol, and Costaria costata. It indicates the different data. And for amino acid, there are huge, good essential amino acids, and the total value is over 44%. Compare with that in rice and starch, the lysis content is much lower. Either the flavor amino acid content is higher. These marks are the asterisk marks the essential acid, the triangle marks the flavor amino acid. While for the total fatty acid, it occupies about 55%, and this indicates the lower lipid contents are good for preventing the cardiovascular disease. And this was some mineral trace elements, and it's contain different content in Saccharinella japonica, cytophenol, lamentaria, and Porphyra hatinensis. In general, there are huge of calcium and iron content rich in the seaweed. While to the other components from the seaweed, for example, the brown seaweed, arginate, fucoidin, polyphenols, and focusins are most important, while to the red seaweed, the agar, the carrageen, the polyphenols, and the phycoerythrin are either important. For green seaweed, we call polysaccharides and polyphenols, which used to be mostly in the fertilizer. This was the chemical structure of arginated. Typically, it have 2 blocks. One is the G type, another M type, because G type glucose contain or exhibited ability or power in antivirus and protect the bone marrow hematophilous cells, while for M-time it exhibited immunological stimulation and reduced the cholesterol in blood. And either for combination for G and B type exhibits the alternate strength and velocity. Certainly, there are different mg ratios and molecular weights from the various brown seaweed, and either they were applied for different applications in food and biochemical fields. While to the coding, it existed in the brown cells wall matrix, and the components contain the L-type focus and 4 positions with sulfate residue. Either it contains xylose, galactose, and others monogalactose come with the protein, potassium, and calcium, and magnesium. And these chemical components were varied with the brown seaweed species, inhabited environment, seasons for harvest, and different parts. Also, it exhibited anticoagulant, anti-tumor, and anti-inflammatory, either it had effect on the diabetic norepinephrine. And from the synthesized consideration, the fucus comes from fucus, and it's with 103 or 103 or 104 glucine. Either it's synthesized with different another direction with adding of sulfate fucins. And finally, it's complicated with various unit of the complex polysaccharides. Previously, our groups published some works, these papers mainly biologically consideration and biochemically stagnation. And to the diabetic neuropenses, we either publish a series of works from point of view of chemical and pharmacological. To the focal senses, it's actually a combination of 2 carotenoids and recently used for food and drugs in all we call the healthy food in China. While to the polyphenols in the brown seaweed, it has multiple functions. In vivo, it can inhibit F-type amylase and F-type glucosidase. And in vivo, it have impact on the hypoglycemia, on the thyroid isolation and beta cell function. Besides, it have moisture and whiteness characters and can contain antioxidation components such as DPPH and OH residues, and have reduction ability and rapid peroxidation. And this can be used for the cosmetic, such as it contains inhibitors for the trypsinogen and the inhibition impact for the medicine formation. While to the last one is we call carrageen and agar-like oligosaccharide. It will also use for food and cosmetic. because different types of red algae, such as Chondrus, Carbaphyca, and Cuma, have different type of carrageen, especially the most used in Philippines and Malaysia or Indonesia for key types or lambda types were very, very used often or popularly. Recently, we conducted some work on the enzyme degradation with carrageenases because it is isolated from different bacteria and for key type carrageenase or lambda type carrageenase. And this was products with combined uses of different types of carrageenases. We can obtain the oligosaccharides and conduct afterwards comprehensive utilization of Carbaphycas by the cellulase and combined key type carrageenase. To the applications of seaweed products so far, there are many actual products we development. Certainly, this was actually conducted in the seaweed enterprise, food or materials in process, such as seaweed daily fiber for clothing, drink, and medical materials, and cosmetics such as masks, and some biostabilizers used for land plants, or some healthy foods we call the functional food used for ordinary people for daily life. In the past, actually, there are very popular techniques and very popular foods we use from the kelp or the liver we use for the seaweed soup, for the sushi, for some instant salted kelp food. And in recent years, there are huge of good companies which they develop many techniques and conduct some instant food and some instant store or prolonger food. For example, with the new development of technology, they use the kelp and use for manufacture the seaweed noodle. And with that, you can contend with some fresh and natural preservation materials. They can be advised to the market, and either to use these materials for seaweed instant soups for rapid change and for customer to the society. These were new functional compounds, both from the instant noodle or some seaweed powder, balkawa, and some seaweed soaps. While for seaweed dietary fiber were development from laminaria and undaria, they manufacture different types of foods. To the nori, we already are actually processing of seaweed products from the first or second processing. And these were the products which were sold to the international or worldwide markets with a high need. And so far, the total world value is about 10 billion US dollar, and China occupy about 1 billion US dollar for liver products. While for seaweed fertilizer, previously, for example, in Europe, in Scotland or Ireland, about over 60,000 tons and 3,000 tons were from these two species for Ascophyllum and Laminaria hyperfera, and it was mainly used for ground growth regulator due to high content of beta-beatins. And so far here in China, there are over 3 seaweed fertilizer enterprises registered in the governmental agency and can yield different types of seaweed fertilizer. For example, for the stimulation the roots, branches, and for maturing some fruits such as grape and apples. And in recent 3 years, there are new fields such as the seaweed as additives used in cow and pig's diet because it could be functioned for food attractant, for enhanced immunology for the cow and pig, and especially very hot topic, reduce the methane emission to the atmosphere and improve the meat quality for these land animals. And another piece is used for seaweed cosmetics and biomedical material. It's already merchandised and sealed in the market. And finally, for new drugs development, as I introduced initially, there are so far 2 main marine drugs, which all from the seaweed. One is FPS, fucodine polysaccharide sulfate. Another is PPS, called potassium polysaccharide sulfate. And it was get a government registered certificate. For the agar and carrageen, it's in Fujian province. Actually, there are huge products, and they extract many different types of aragine and carrageen, and either use a daily fiber and either for recent year for the capsule usage, because for the Muslim tradition, it needs these types of capsule without any additives from animals. And this was very positive for the Southeast countries, especially for the Muslim markets. Problem. Actually, even though we conduct huge work, both basically and in price size, even to the merchandise product, it still needs to judge the seaweed resources for guarantee the food safety if we use for food. Because in these 10 years, our central government and local government are very aware of these issues. Food safety is very important. Second, full utilization of seaweed is another question because it's very hard to extract only one component from the seaweed. So we need to extract full utilization techniques for complicated usage of the material. Third one, the extraction techniques and application improvements are still highly needed in the future. And to the perspective, we think it's not only applied in food field, but also in biomedical or other field. So, for example, the carrageen-like components are still in use for dietary fiber, for meat industries. And the high qualified agarose preparation and application in molecular biology is a cutting-edge topic in this field because of the high qualified agarose, the problem, I think, still not be solved completely. For agriculture fertilizer, for their application for land plants, I think there still existed a lot of problems, and people should encourage do the more wide application for land plants. We should enhance the seaweed extract as addictive in diet for cow and pig. And this was very held in European field, and we are now seeking the partners in the worldwide, especially for European countries. Finally, the regional and global cooperation are highly required. For example, we still strengthen our collaboration of partners in the Southeast countries. Finally, I should extend my thanks to the ANI for UPV in Philippines, Global in Indonesia, and Japanese partner in Hokkaido, and some Chinese partners in Ocean University of China, and Dalian University in China, and our institutes. And especially thanks to some good and big civil companies in China, such as Shandong Gaolü Fishery Limited Company, Jiangsu Yancheng Harry Fishery Company, Qingdao Bright Moon Seaweed Group, and Rizhao Jiejing Seaweed Group, or Fujian Jinyang Seaweed Group. Either I should extend all my thanks to my students or assistants in my team. Finally, thanks for your listening.
Thank you very much, Prof. Delin Duan. So we should give appreciation. Thank you for sharing very comprehensive overview of Prof. Delin Duan work. And the committee would like also to give a certificate of appreciation to Prof. Delin Duan.
Thank you.
Thank you, Prof. Delin Duan.
Yeah.
Before we continue to the next speaker, I would like to encourage our online participants who would like to send questions to our presenter. Participant can send the question through the chat box. In Indonesia, also you can send the question in English or in Indonesia through the chat box, and we will translate it later on. So, ladies and gentlemen, we are now come to our third speaker. Dr. Victor Nikijulu. Dr. Victor, are you here with us?
Yes, I'm ready.
Thank you very much. So I will also give a very brief introduction of Dr. Victor Nikijulu. Dr. Victor Nikijulu was the former Director General of Fish Processing and Marketing of the Indonesian Ministry of Marine Affairs and Fisheries. And he's the Executive Secretary of the National Coordinating Committee of the Coral Triangle Initiative on Coral Reefs, Fisheries, and Food Security. He initiated the formation of 11 fisheries management areas and are now implemented in Indonesia. When he was the Director of Research Center of Capture Fisheries. He has a lot of list of job publication here, but I would like to mention one that he received his PhD in Resources Economics from the University of Philippines in Los Banos in 1994, where he was awarded the best PhD dissertation in the School of Economic and Management. Without further delay, Prof. Victor Nikijulu, the time is yours.
Thank you, Madam, for nice introduction. Excellency, ladies and gentlemen, thank you for having me in this prestigious seminar. Can you hear me? Okay, can I get a reaction feedback? Can you hear me?
We can hear you very well.
All right, very
Dr.
good.
Victor.
Can someone help me to present my PPT, please? I have shared my PPT materials to the organizing committee, and can someone help me to show it?
Yes, Pak Doctor, we'll share the PowerPoint for you.
Okay, thank you so much. Yeah, let me, I'm now working at Konservasi Indonesia. It is a national partner, main national partner of Conservation International. Conservation International itself is a global conservation organization based in Arlington, US. And we work right now in 5 continents, more than 70 countries, including Indonesia. Before, Conservation International was in Indonesia for about 20 years. But then the works of Conservation International Indonesia is now replaced by Konservasi Indonesia. Again, thank you so much. I will share with you, ladies and gentlemen, Excellency, I will share with you a new concept that is recently developed by the government. Sorry, I got a feedback. I hear a feedback. Can we continue, please? Okay, next slide, please. So, as you can see from my title of presentation, the title is about blue halo as concept, which is basically an integrated approach of protection and production. Konservasi Indonesia is working with the government, central government agency, which is coordinating Ministry of Maritime and Fisheries and Ministry of Fisheries and Marine and Fisheries, and many other agencies to develop this concept, and it is being developed right now. And we have a target that the blue halo S or protection production approach will be officially introduced or announced in the coming G20. G20, there will be a special session on ocean, which is called Ocean 20, will be in the 13th or 14th of November. And we hope that we can introduce to the global community about the blue halo, which is applied in Indonesia. Blue halo have been applied in many countries, but recently, as I said, we work together with the government to develop this concept. It is basically an integrated approach between protection and production, where those 2 components are working together and try to be managed in one room, or those 2 components are managed at once. In a way, the impact of protection can affect the production. On the other way around, production can also be utilized, be developed by considering the protection aspect. Okay, ladies and gentlemen, in this slide, I only have like 10, 11 slides, so I will end my presentation hopefully less than 25 minutes. Basically, this slide want to illustrate to you problems and change encountered by our country. There are many lists. I put it here in the slide, including climate change that have been alluded by Professor Lim and Professor Deon. But basically, I want to focus in the main problem faced by our country is the overfishing. Here in this country, we have 99 fisheries. I will explain about it later on. 9 fisheries, and the 9 fisheries, about 90% has been either fully or over-exploited. This is basically serious problem faced by our country, especially the fisheries industry or a blue economic as a whole. If you want to put fisheries as one of the blue economic component. But the same time, government also promoted to develop. Right now, the target is 32.5 million hectare of the marine protected area. So it is by 2030, which is called 2030 vision. The government want to have like 30.5 million hectare marine protected area, which is well managed. And the current figure is 28.4 million hectare MPA have been developed all over the Indonesia. And it is including the one managed by the central government, but most of the MPA are managed by the local government. So you know, comparing the overfishing and the protection, which is represented by the MPA, of course, we have also other protection measures like, or other protection strategy like species protection, then focal spaces protection, area protection as part of the fishing ground. But I just want to focus on the MPA, marine protected area, which is basically a particular regime specifically developed to protect our resources. And hopefully from that protected area, there will be kind of spillover effect that will affect our fisheries. So basically in this slide, I want to show you there are many problems faced by our country, but our main problem is the overfishing and how the government have tried to overcome the problem of overfishing by many strategy, but one of these is establish marine protected area. So marine protected area and the fishing ground or fish stock should run all together in order that there will be connectivity, interrelationship between those two principal components. Next slide, please. Okay, as I said that this is the recent decree issued by Ministry of Marine Affairs and Fishery 19/2022, just a few months ago. But this slide want to show you that our fisheries, this is condition of our fisheries. We have 11 fishing ground. 3 fishing ground are part of the Indian Ocean, and 8 fishing ground part of the Pacific Ocean. So all in all, we have 11 fishing grounds. So we categorize or we divide our fish stock into 11 fishing ground. And in terms of species, we divided it into 9 species, 9 group of species, starting from small pelagic, there's a large pelagic, demersal, coral fish, penite shrimp, lobster, crabs, and swimming crabs. So, and lastly, a squid. So by cross tab, you will come up with the 99 fishing grounds. And you can see from the figure that most of the fishing ground or most of the fishing stock have been fully or overexploited. Next slide, please. This is like summary of our fish stock condition. In 2015, we have a 42 red stock, 45 yellow stock fully fish, red stock overfish, and we only have a green stock which is 11. So 11 green or underfish stock. And if you compare over time temporal analysis, you will come up with the 2022 that red stock becoming number of red stock becoming lower. Right now is 35. Yellow slightly increased to 63, but the green one is still 11. This slide indicate that, of course, there's an effort to improve the condition of our fishing ground, but most of the fishing ground, as I said before, most of the fishing ground are still in the red and yellow condition. We still have huge effort to increase the condition in a way the numbers of the green stock should be increased. So basically, this is an idea about a problem that we are encountering right now. Next slide, please. The MPA, as I said before, we have fishing ground, but the other things we have a marine protected area, and so far until today we have 28.4 million hectare MPA all over Indonesia, but you can look from the figures. Most of the MPA are in the eastern side of the country, in the eastern fishing ground. A little bit, so most some are in the Riau Islands, but most of the MPA are in the eastern part of the country. You can see the distribution of the MPA by the fisheries management area, and yeah, most of those are in the eastern part, in the province of Papua, Maluku, and in East Nusa Tenggara. We have like 3.2 million hectares of MPA in East Nusa Tenggara, which is cover this part of the Sahu Sea. But this number of MPA, this is I took the slide from Dr. Firdaus from the Ministry of Marine Affairs and Fisheries. One of his slides is mentioned that basically the numbers of the MPA is too low. It is only few to provide the impact, the significant impact. It is too low to protect the habitat for fisheries. Of course, we need more space and more protection. And there's one benefit that can be derived from this MPA is developing of the ecotourism. Basically, this slide just want to show that even though we have an MPA, but the numbers of the MPA are too small, the management accommodation is not so well in a way that the MPA can impact the fishing ground or fish stock. Next slide, please. Okay, ladies and gentlemen, this is a new slide. I also adapted it from the Dr. Firdaus slide, which is telling us about Indonesian ambition or target to develop MPA all over Indonesia. As I said before, by MPA Vision 2030, the government have decided that numbers of MPA all over Indonesia will be 32 million hectares. But just recently, the government announced that by 2045, in conjunction with the 100 years of our independence, government will have a target to expand the MPA from the 32 million hectare target right now to be 97.5 million hectare in 2045, or close to 100 million hectare. This is basically a new target that will be announced by the government, and it will impact a lot to our fisheries. And we hope that as evidence that have been shown in the previous slide, that the current MPA do not have an impact, the good impact, but we hope with this target, with this MPA that will be established to about 100 million hectare, the protection and production management can be realized. Next slide, please. Okay, macro blue economic, as mentioned before, as alluded before by Professor Lim and Professor Delon Duan, and even in the opening speech, that this country is endowed with the huge resources. We have a coral reef, we have a seagrass, we have mangrove. Even for the mangrove, we are the largest country in the world. In the term of the production, we are global ranking. Currently, we contribute, the fisheries and aquaculture contribute about $27 billion of our GDP, and the marine and coastal tourism contribute about $26 billion of our GDP. There are 3 million people directly engaged in fisheries, but considering or taking into account processing, marketing, those who are working in the fishing base area, in the fishing port, all in all, we come to about 6 million people. So directly and indirectly, there are about 9 to 10 million people in this country who are depending on the fisheries or marine sector. Of course, Indonesia have also other target of developing like tourism, developing of other sectors that are dealing directly with the marine ecosystem. Next slide, please. Yeah, there are 4 pillars just recently introduced by the government in connection with the blue economy. Blue economy itself is one of the pillars, but other things you can only have blue economy if you have other pillars to construct the development of the marine sector as a whole. So I call this like a macro perspective of the sector of the blue economy in Indonesia. One is the blue health. We hope that we can have we will have a sustainable management mechanism to manage our resources, which is basically providing income and livelihood to our people. But then we need blue innovation. So science, research and science, monitoring part of this component, blue innovation. Our main issue is how to harmonize effort to promote the blue science and technology. The third one is the blue economy, has been discussed before, the component of the blue economy. But basically problem that we are facing right now is the lack of capital, lack of innovation, business model that are dealing directly with the development of the blue economy. And the lastly, but more important one is the blue finance. Blue finance is another pillar. And if you just depend on the state budget and there's no enough room, fiscal rooms to develop the blue economy, so we need kind of financial structure, new structure in a way that all the blue economic component, the blue health component, and blue innovation component can be developed. Next slide, please. Of course, this is basically based on the previous slide, based on my previous explanation, and then we come up with the idea of the blue halo. So how blue halo can be introduced and how blue halo can partly overcome the problem that I said before. So what is the blue halo? Blue halo is consists of the two main component. Blue component is basically protected area, marine protected area, but it also includes protected mangrove, protected seagrass, protected spawning and nursery site or nursery ground. And we have the blue halo in particular place, and we have the impacted fishing stock. So fishing stock or fishery which are affected or influenced by the condition of the blue component. So you have the inner circle. If you look at the slide, you have the light blue circle, which is basically the protected component, and you have the blue cycle. The outer cycle is basically the halo component of the impacted component. So basically, this is the blue halo that we are introducing right now, that are being worked by the government to implement it in some pilot area in Indonesia. Next slide, please. This is the extended model of the blue halo. So you have a blue component and you have the halo component. And by having a good managed and effectively managed blue component, you will come up with the fish that are out migrated from the blue component to the halo component. And it is basically the scientific terminology that we use for that is the spillover effect. So once you have a blue effect, blue halo component, and then a blue component, and then manage it properly, and later on it will affect the fishing ground. And the commercial fishing ground, if you catch and you manage the fishing ground at the certain level, at the best level, we hope that the uncatchable fish will come back to the blue component for the reproduction process. This is the blue halo that we are introducing, that are being introduced by the government and the private and the NGO like us right now, and started with the concept development in Jakarta in Indonesia, but we hope that very soon it will be applied in the part of Indonesia. Next slide, please. And this is the extended model of the blue halo protection and production. Of course, to carry out, to implement this model, we need the sustainable financing, and we hope that by having a very good fish stock, and private sector can generate income profit from the fishing, but we hope that part of the fishing can be ploughed, can be put back to the hollow component, to the blue component, in a way that process of management of the protected area can be improved. And then we have a capacity building of organization and strengthening. Of course, since this is a new concept and we should introduce the capacity building, global and regional outreach. We are now working not only in Indonesia, but also we are working with some agency, global agency, international agency, even with the international private sector to introduce Blue Halo, as the concept have been developed in several countries, such as in the country in the Pacific. We hope that we can learn also from those countries, and what the good things that can be learned from there, we can bring it to Indonesia and adjust and develop our system in Indonesia. Of course, part of the Blue Halo component you may see in the figure is the social economic empowerment, especially for the micro, small, and medium enterprise. Next slide, please. Like a takeaway from this short presentation. This concept, as I said, is being developed right now, but we have started gather data, scientific data, in order to prove that there is a relationship or connectivity between protected area and the fishing ground. We just finished a study carried out or led by the University of Patimura in Ambon and the University of Nusa Cendana in Kupang, to carry out study in the 3 fishing ground, Banda Sea, Seram or Sea or 714, 715, VPP 715, and the Arafura Sea. Basically, we want to collect more data in order to show that there is a relationship or connectivity between fishing ground and protected area. So what we need is those kind of data will show later on, or will give a feedback for us how much we should, as I say before, plow back profit that can be generated from fisheries to manage or to finance the blue component. So we need more science, and we hope that this science component can be led by the university, especially to show the impact of the protected area in East Province. We hope that state university in East Province can develop this study, scientific component, not only in the research, but also in the curriculum development. Right now, we develop Blue Halo S101. It's a basic concept of the Blue Halo. And we have carried out like a seminar discussion in order to design a Blue Halo S101. It is basic course 101 curriculum. A policy component of Blue Halo S need to be framed by disentangling the existing rule and regulation. We have the existing rule and regulation right now, and based on those regulations, we will derive the concept of how to implement the Blue Halo. No need to have we don't need to have a kind of regulation at the low level or at the national low level, but what we need is kind of presidential order by which implementable rules and regulation at the ministerial level and at the DG level can be passed, can be issued as a basis for the Blue Halo implementation. As I said before, not only government, right now we are working together with the civil society organization, including our organization, Conservation International. And at the global level, this idea have been introduced by our leaders, by our ministers. And right now, there's a positive sign that many international organizations also pay attention on this and want to participate in the development of the Blue Halo S in Indonesia. But what we need also, the role of the CSO is in advocating toward the improve of the governance, empowering community as the main beneficiary. So at the end of the day, what we hope from the Blue Halo S is basically the better and improved livelihood of our fishermen or of our fisheries. The last thing is the Blue Halo S should be applied in all fisheries management area. For our case in NTB, we have at least two fisheries management area that border NTB province, which is 572 at the southern part, and at the northern part it is 713 FME, part of the Flores Sea. So we hope that in 11 fisheries management area, Blue Halo can be applied, but to start the Blue Halo, the government just selected 571. It is the waters of the west coast of Sumatra, which is cover 6 provinces. We are now working with the local government, with the central government, to develop Blue Halo as implementation in that fishing ground, West Sumatra fishing ground. But we hope that this concept can be developed. But of course, we still need a lot of data in a way to prove all the stakeholders that the Blue Halo could be one of the strategy for our improve or better fisheries in the future. Ladies and gentlemen, that's the end of my presentation. Thank you so much. And as I said before, Dr. Ateng is in the States, and if there's a question, comment about this, Dr. Ateng will help you to entertain those questions. Thank you so much, and back to you, Madam.
Thank you very much, Dr. Victor, for very interesting presentation. Again, the committee would like to send the certificate of appreciation for Dr. Victor Niki Julu.
Thank you.
Dr. Victor.
Thank you
very much. Ladies and gentlemen, we have come to, we should move to the next session, which is discussion. There are already some questions in the chat box, but before I invite the presenter to answer the question, I would like to invite 3 questions from our offline participant, please. Bu Made? Yeah, and the one there, and one more question from the lady in the middle. So all 3 ladies will give 3 questions, and please, the first one is Ibu Made. Please state your name and to whom the question is addressed. Ibu Made.
Thank you very much, Dr. Alam, for the opportunity. So my name is Made, and I would like to ask a question to Professor Jalil Duan. It is very interesting topic that Professor has delivered to us. So one of the highlight that is really interesting for me is the prospect of using seaweed as an additive in a cow and pig. So I would like to ask you more. Would you please inform us on how seaweed in relation to livestock is used or applied in China? That's the question. Thank you.
Thank you, Bu Made. Next question, please.
Good morning, ladies and gentlemen. Thank you, Dr. Aul Hikmatullah as moderator for the opportunity. My question to Prof. Delinduan. My name is Hasriatan Fatmi. I'm fresh graduate of Biology Department, Faculty of Mathematics and Natural Science, University of Mataram. I have been working on molecular doping study about screening 24/7 bioactive compound promoting as antiviral SARS-CoV-2. My result is there are 6 selected compounds that have promoting as SARS-CoV-2 antiviral such as fucosantin, cifosantin, and lambda-paraginan and alpha-paraginan. But from the result, lambda and alpha-paraginan have molecular weight is up to 500 Dalton. It means from the reference that the molecular weight is up to 500 Dalton is hard to pass the cell wall. My question is, it is possible to depolarize molecular carrageenan molecular weight become a smaller molecular weight. This my question. Thank you for your kindness, Prof. Delinduan. Thank you.
Thank you, Pak Fatmi. And the next question from the lady in the middle. Please state your name and to
Now,
whom the question is.
It's my answer first for the 2 questions, and they are very, very good questions. I think I just try to answer briefly for the second one. First, it's really possible for the researchers, I mean, indoors in the labs, for both chemically and enzyme measures to dissect the polysaccharides from the carrageenan noise, such as incuma and carbofica. And if you want to do the works, I suggested it depends on your preference. You can first dissect it in, mechanically is maybe more feasible for some researchers, but it will depend on the usage of these oligosaccharides. However, if for enzyme digested polysaccharide or oligosaccharides, you can be used the enzyme method, or you can use in combined way for these, the final substance you prefer to obtain. It's okay? For the first question, I nearly forgot can you repeat it again for the questions?
Yes, the first question is from Ibu Made.
Yeah.
She asks the prospect of using seaweed to livestock in China. Do you have any experience that
Pardon?
the prospect of using seaweed?
Pardon?
Livestock.
Well, actually, for brown seaweed and red seaweed, for example, for Succulenta japonica and Undaria piniphytata, we used isolated gametophite as seed stock and preserved for long term, and the lower seawater temperature, suddenly it was filtrated with a series of process. However, if for the porphyra we use the gametophite, actually use a concaulated stage as seed stock for preservation. However, for the carcinoid types seaweed, so far we did not concluded ideal and good strategies for preserve and keep it in the labs. For example, as I visited several times in Jakarta and other universities in your country, either visited the labs in Philippines, we found that it used to be cut in a very, very small branches, and I mean segments for the seaweed stock indoors preservation. However, with long-term preservation or persistence, it could be decay or become white, or we call it white disease, somehow like that, because it's usually with unsexual production. So we are wondering to whether there are no more better strategies for preserving this type of red algae in the tropical areas. It's a challenging topic, frankly, I think.
Thank you, Prof. Delin. Before we go to the next question, so I would like to invite Prof. Lim Paik in first to answer some questions from the chat box from the participant. Prof. Lim, are you here with us?
Yes, I'm here. Yep.
Yes, the question for Prof. Lim in the chat box is from Professor Srividya Stuti. Yeah. Do you get the question, Prof?
Yes, okay, I can address. So, Prof. Vidi, thank you for your questions. You are raising the important issue of the metal contamination of seaweed in general. I think when we talk about seaweeds, I mean, besides they are good food resources and high in minerals and nutrition, but they are also another aspect that we have to pay attention to, because they are a very good bioabsorber. So means that based on the location they are growing, they also can absorb, especially the heavy metals of concern. So I think this is something that the national should come out in terms of the guideline for especially for food production. If you talk about in terms of the guideline, unfortunately, I think for Southeast Asia country, we are behind in terms of guideline on the safety and the level of contamination. However, I know that I understood that in China, they do have a very clear guideline in terms of the heavy metal, as well as the microorganism composition contaminants, the factor, what are the parameters that look into, which I think Prof. Delin Duan can further elaborate in terms of the biosafety of the seaweeds as a food. Yeah, I think we need to develop for our own sets of food safety guideline for our tropical species. Yeah, that's all. Thank you.
Yeah, and the second question for Prof. Lim is from Padmi. Her question is, how the seaweed industry could sustain from the impact of climate change?
Okay, thank you, Padmi, for your question. I think they are very important, because if we talk about to sustain the seaweed industry, especially for aquaculture in the midst of climate change, I think this is something that's challenging, and it won't be a single approach that actually we can tackle to it. We know that the international community have been raised out the concerns to how we can reduce the increase of temperature and keep it at 1.5 to 2 degrees Celsius. But the thing is, we know that in order to achieve that, there's a lot of effort that we come to. But at the moment, we are facing climate change. So firstly is, if we talk about, I will use Yukimata as example. Firstly is the strain and the species that we are cultivating now worldwide. We are actually using the same mother plants that have been cultivated for more than 50 years since it's first time introduced. And this is actually proven by the study that we carry out, including Dr. Eka on Indonesia. The genetic diversity that we are cultivating, the genotype is very limited. It's only up to 1 to 3. Not only Indonesia, not only Malaysia, but worldwide. So when you talk about low genetic diversity, it means that if they are facing any challenges in terms for growing, it is easy to be affected and can be wiped out easily due to any disease or impact from climate change. So the first, most important now, I will say, is that we have to increase the effort to look for new cultivar. So this new cultivar means that we have to develop from the world population with a different genetic makeup, or in short, we say different genotype. And then hopefully, in hoping that we have to test the strain and species to be climate resilient. And for Earth tropical, I think the most important factor or severe factor that is affecting us is global warming. So, and we hope also that because with global warming, if increase the incidence of pests and disease, we also have to look that they are versatile to pests and disease. Then of course, with the increase of, we also need to look into in terms of the environmental or growing factor, where we are growing seaweed, we have to keep the water pristine, free from pollutants, and that's where we'll link to food safety as well as the survival rate for the aquaculture. So I think this is, I raise up the two most concerned, but of course there are many other factors that we still have to look into. Thank you for your question, Patmi.
Thank you very much, Prof. Thank you very much, Prof. Lim, for the
Most welcome.
Yeah, so there are several issues actually has been raised during this the presentation and discussion in this in today session. There's some might be challenges, and we should address it. I think in global collaboration. For those reasons, I would like to invite Prof. Buan Ansari from LPPM University of Mataram, and how UNRAM in the future could address these issues, and how UNRAM could also collaborate with many parties to try understanding what we are facing now and how this seaweed industry will also be sustainable in the future. Prof. Buan, it's time for you.
Thank you, Dr. Alu, for opportunity to deliver some summary of what's our role. I'm research coordinator of Research and Communities Institutes in Mataram University, and I'd like to deliver about what's our role to express the vision of our university is becoming a research-based and internationally competitive university by 2025. It's very close to the target of our mission. So the role of our institute, Research and Community Service Institutes, lastly, we arrange a master plan of research with the time range 2020 until 2024. This master plan research already approved by the Academic Senate of Mataram University, I think last year, December last year. So our focusing now, we are refocusing the research in Mataram University with five main topic and five special location in this research. The big topic is how to sustainable management of small island. As we know, in Nusa Tenggara province, there are two main islands, Lombok Island and Sumbawa Island, and about 378 small island. And from this almost 400 islands, there are 32 island inhabitants, so inhabited in 32 islands. The five main topic of our research in Mataram University is, the first one is food. This is the first one. The second one is health and medicine. So this two is very related with what you present from the keynote speaker, Prof. Lim, Prof. Delin, and Dr. Victor. And the third one is energy. The fourth one is environment and tourism. This is relevant as well with the speech from keynote speaker. The fifth one is education, social and economy, law and humaniora. So this covers, I think, very related with the topic from Dr. Victor or Dr. Ateng next. And there are five locations. There are five locations we are focusing in the next 4 years of Mataram University research. The first one is Geopark Rinjani. This is the special location we focus research. The second one is Mandalika. It's very famous with the location of circuit Mandalika. This is the south part of Lombok. This is economic zone exclusive. The third one is Alas Hijau Straits. This is the strait between Lombok Island and Sumbawa Island. We said Alas Strait. We are focusing as well in this location. And the fourth one is Samota area. Samota is the acronym of Saleh Bay, Moyo Island, and Tambora area. This is in Sumbawa Island. We are focusing as well in this location, special location, Saleh Bay, Moyo Island, we call Samota area. And the last one is Sakosa area. This is the acronym of SAPE, Komodo. Komodo is Nusa Tenggara province, and Sangiang. Sangiang is the volcano in Sumbawa Island. So this is the, I mean, the big opportunity of us, Mataram University, for further collaboration with the or institution or the abroad or in Indonesia to make a collaboration in the future. I think that's all I want to deliver to Alu.
Thank you, Prof. Wan. So, ladies and gentlemen, it seems that in the future there will be more collaboration between University of Mataram and other university to try to answer some of the challenges that we face at the moment, including the impact of climate change to marine industry. Before I go to the next question, I would like to have Pak Atang to give some comment regarding some issue that has been raised, particularly with this pollutant, contamination, as well as about the food industry and climate change, and how it could benefit the blue economy, particularly regarding this marine protected area and the blue halo. Maybe we should hear some more explanation from Pak Atang.
Thank you, Madam. Maybe I'll focus about our future collaboration between Yayasan Konservasi Indonesia and Universitas Mataram. based on our program or our project. For the seaweed, we already have a close collaboration. And our goal is to like the presentation from Professor Lim, Conservation Indonesia. Yayasan Konservasi Indonesia is the main partner of the Conservation International that we try to explore the new species or the new seaweed for the cultivation in Indonesia, not only in West Nusa Tenggara, but also in the East Nusa Tenggara. So in this collaboration, we will apply it for the blue economy based on the government's target. So this is the first for the seaweed. But another is we have another activities supported by German government in the Somakor. We will work in the this is a blue economy also. We will work for the whale shark in West Nusa Tenggara, that we will increase the availability or the whale shark in Teluk Saleh, West Nusa Tenggara, to increase the tourism, marine tourism. So I think having a lot of activities that can be improved, or we can collaborate with the Mataram University. Not only on the seaweed or blue whale shark, but also another activities, another program for example, for the mangrove restoration, because this is support to increase, like Pak Victor presentation. We support the blue halo, but it means we will provide the availability or the rich marine or fishing ground area in our fisheries management area by develop or increase the management of the marine protected area. I think we need a collaboration for the next future about the MPA, because this is very important to provide the fish stock in our fisheries management area, and also we will support for the fisheries policy that will encouraged by government. Thank you, Madam.
Thank you very much, Pak Atang. So, Pak Atang Supriyatna. Pak Ateng Supriyatna is the program manager, fisheries and aquaculture program manager from Yayasan Konservasi Cakrawala Indonesia. Thank you, Pak. And ladies and gentlemen, we are limited by the time. It seems that there are some more questions, and some questions which in the chat box that has not yet been answered by our keynote speaker. We will direct the question to the keynote speaker, and then later on the committee might send the answer to the audience. Yeah. So without continuing this session, I would like to say thank you very much to all of our keynote speakers for outstanding presentation, and for them to be able to attend our ICBB 5 ICBB conference. Thanks also to all participants, the online participants, as well as the offline participants today, who making this session very productive and interactive, I think. Yeah, and I think we should end this session now, yeah? By saying again, thank you to everybody. Good afternoon. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Saya kembalikan ke Kuntildan.
Check. Thank you very much, Professor Lim Pek Im. Thank you very much, Professor Duan and Dr. Victor Nikijulu, for such informative and insightful presentations. And thank you also to Prof. Buan and Prof. Ateng for joining us in this session. And thank you, Dr. Alu, for leading the session. Thank you very much. And ladies and gentlemen, we are now holding a lunch break. Okay, and for those joining the second plenary session, please be noted that our session will start after break at 1:30 p.m. for Indonesian Central Standard Time. So I'll see you soon, and you are welcome to have the lunch that we have served. Thank you. The lunch has been served on the first floor. Good afternoon, Dr. Cahaya Kurnia Fusianto and Professor, sorry, Dr. Kim Lee Chang. Okay. Okay, we are sorry for being late, and there is an issue this morning, so we have kind of weather issue happening. That's why we're kind of late to enter this room and to start this program. So we're very sorry for that. And Dr. Cahaya, are you there? Dr. Cahaya? Dr. Chang? Dr. Chang? Are you there? We're still
Yes,
waiting.
I'm here.
Okay. How are you doing?
I'm good. I'm good. Alhamdulillah.
Okay, good. Alhamdulillah. Saya, if you don't mind, we wait for a minute for the participant to enter this room, since they still have lunch break right now. Does it sound good for you?
Yeah.
Thank you so much. What about Dr. Chan? Dr. Chan?
Yes, hello.
Yeah. How are you, Dr. Chan?
Very good, thanks.
Thank you. As I said before, we are very sorry for being late, since there was an issue this morning related to weather issue. So we were late to start this program. And now we're still waiting for participants to enter this room, and now they are still having lunch break. Do you mind if we wait for a minute, Dr. Chen?
That's okay.
Okay, thank you very much. Okay, ladies and gentlemen, participant of this program, I would like to invite everyone to come to the room, to enter the room, since we are going to start the other session of keynote session. Excuse me. Ladies and gentlemen, the next session is going to start in 5 minutes, so please be seated.
Check.
Okay, ladies and gentlemen, the next session is going to start, so please be seated.
Recording in progress.
Excellencies, ladies and gentlemen, for the second plenary session, I would like to invite our moderator today, Dr. Eka Sunarudi Prasadya. Dr. Eka is a lecturer at Faculty of Mathematics and Natural Sciences, University of Mataram, and he is also a researcher as well as the head of Center of Excellence for Bioscience and Biotechnology, University of Mataram. He's got his bachelor degree from Faculty of Biology, University of Gadjah Mada. He's also got his master degree from Institute of Ocean and Earth Science, University, Malaya, Malaysia. And he's got his doctoral degree from Department of Cellular and Integrative Physiology at at Fukushima Medical University, Fukushima, Japan. And also, I would like to invite all our keynote speakers, Dr. Cahya Kurnia Fusianto, Dr. Kim Lee Chang, Associate Professor Kato Yasuhiro, and Dr. Munawar Halil. To Dr. Eka, time is yours.
Okay, good afternoon. First of all, Dr. Cahya and Dr. Kim, Professor Kato, and Dr. Munawar Halil, are you already in the room?
Yes.
I think so.
Thank you. Thank you.
Yes.
Yeah, I would like to apologize for the delay of our program. So we should have started maybe 30 minutes before, but due to we had some obstacles in the opening ceremony, that's why we started a bit late. So again, I want to apologize deeply on behalf of the ICBB committee. So just to shorten the time, and we have already run out of time already, I would like to welcome the first speaker. He is actually a good friend of mine during my bachelor degrees in University of Gadjah Mada. So Dr. Cahya Kurnia Fusianto, he got his bachelor degree in University of Gadjah Mada and continued to master's in biotechnology in University of Gadjah Mada and continued to get his PhD in University of Sydney, Australia. And now he is a research associate in the Michigan State University in USA. And he is an expert in fish diseases. And he just told me he just came back from salmon sampling. So it's very interesting. And I hope that Dr. Cahya will share some of his experiences in that field and would hopefully inspire some of our young students that who are attending. Yes. So Dr. Cahya, I'm here also with Dr. Zainal. He is also studying fish aquaculture. Hello. Okay. So Dr. Zainal also studied fish diseases in Taiwan and with his PhD there. And here's Professor Sulaiman, his expertise in proteomics and in the biotechnology field. And they accompany with me today in the front to probably, hopefully we have a fruitful discussion in the session 2 of the keynote session. So without further ado, I welcome Dr. Cahya to start your presentation. So please, you're welcome, Dr. Cahya.
All right. So can I start now?
Yes, please, you can start.
Okay, well, thank you very much, Eko, for the opportunity given to me. So today I would like to say about viral diseases in aquaculture, diversity and biosecurity. Okay, so I will start with why aquaculture is important. A human population is growing and gives pressure to global food production to increase the productivity. From 1961, fish consumption increased by 3.1% per year, while other animal protein food increased only by 2.1%. So this indicates that fish consumption is become more popular. And in 2020, from the total of fish production, aquaculture contributes about 49% of total fish production and is increasing compared to the capture fisheries, which is relatively steady or even decreasing because of some reason, can be overfishing or any environmental issues. And this data shows that aquaculture becomes the future of fish production. Now I would like to talk about constraint in aquaculture production. So the first is nutrition. So problems related to nutrition mainly regarding to how effective the food is used by the fish, or we can call it food conversion ratio. So this ratio impacts to the cost of production and the quality of the aquaculture product. Then environmental issue. This can be related to physical aspects such as oxygen, ammonia, and temperature. So, and every aquaculture community could have specific needs for these aspects. And disease. So when we culture fish in high density, then disease can be occurred because of the transmission can be easily happened and the disease can be easily multiplied. And the common disease in aquaculture are first parasite, then bacteria, and then viruses. So in the nature, usually, so it's very rare to have only one disease, usually combination or co-infection among these pathogens. And in this opportunity, I would like talk more about viruses. In order to control disease in aquaculture, World Organization of Animal Health, formerly known as OIA, released list of notifiable disease. And the criteria are, first, the pathogen can spread across the nation via aquatic animals or animal products or any other factors. Then at least one country restrict or declare zone of freedom from the disease. Then a precise case definition and at least a reliable diagnosis are available for this disease. And also the disease should negatively impact the cultured animals or scientifically proven would affect the animals. So these are the criteria to be listed as notifiable disease by World Organization for Animal Health. Okay, so OIA has a list of notifiable disease in aquaculture. In this opportunity, I would like only talk on a few of them. So I will talk about white spot syndrome virus, cyprinid herpes virus 3 or koi herpes virus, tilapia leg virus, and infectious spleen and kidney necrosis virus. So that's the first white spot syndrome virus. So this virus has double-stranded circular DNA with a pretty big genome size, up to 300 kilobase per. And this virus is very deadly, with mortality rate up to 90% only within a week. So very devastating. And the worst thing is the virus has a quite wide host. Almost all peanut species susceptible. So this is a picture of white spot syndrome virus in Penaeus monodon, and this one in mud crab Bacillus serrata. Clinical signs. So the affected animal will have calcified spots, white, so like this. And the shrimp, so it will be within the exoskeleton of the shrimp. And then they will just slowly move, and they don't want to eat, decrease or absent. So you can see usually affected animals, shrimps, become skinny, and also abnormal behavior, including swimming. They usually just slow swimming or just swimming on the side of the net or near the water surface, and usually catering. And the infection of this virus can be subclinical, so mortality can happen without any signs. So yeah, it's very dangerous. And for diagnosis, histopathology, this virus infection displays typical viral infection with enlarged nuclei. So this is indicates that the viral replication is happening inside the cell. So this is the SSV virion. And so histopathology, you need an expert to interpret the result, and a more robust diagnosis method to confirm this disease is PCR. So OIA lists nested PCR. So this is conventional PCR, and also Tuckman qPCR, which is more sensitive. The sensitivity of this method, the Tuckman qPCR, is 4 copies of the virus, so it's really sensitive. And also in situ hybridization. So this method also mentioned in YA, and so it will look like this, the fancy fluorescent, which can specifically display the virus in the organs. And global distribution, and this virus has been reported anywhere when shrimp is cultured. So you can see in the US, Mexico, Brazil, some part of Africa, China, Indonesia, India, Australia. Then for the next virus, cypriot herpes virus 3 or koi herpes virus. This virus has been listed in notable animal disease since 2007. And this virus also deadly with mortality rate up to 100%. And interestingly, this virus is very specific, create mortality only to common carp and koi. So the other species can be infected, but usually not lethal. So you can see here spectacular mortality because of cypriot herpes virus 3 or koi herpes virus. Many fish can, many carp, common carp can die within very short period. So this is really devastating. excuse me. For the clinical sign, we can see kill necrosis or discoloration or necrotic patches. So it is also called dirty kills. Sorry. So this is typical of the coherpes infection. They start the infection from the gill and then spread fastly to kidney, heart, and spleen. So when the infection getting more severe, so you can identify, detect the virus in every organ. And then for diagnosis, KHV can be identified using specific monoclonal antibodies, such as indirect immunofluorescent microscopy and in situ hybridization. So kind of like this. This technique can specifically identify KHV variant in the tissue. However, in the OIA, they mentioned this technique has not been compared with other techniques, and it can be cost extensive. The gold standard for the KHV diagnostic is PCR. And this is quicker and more reliable. OIA recommends 4 sets of primer to identify KHV. This is Berkovier thymidine kinase primer, and then Gray SPH primers. So it will look like this using a conventional PCR. And global distribution, this virus has been reported the same with white spot virus anywhere when carp is cultured. So yeah, literally when a country cultured carp, so or carp person there will likely to have KHV report. And tilapia lake virus. This virus is new emerging virus in aquaculture. This RNA virus firstly reported in Israel 2009, published in 2014. And again, deadly. So the mortality can be up to 90%. And the host is also known more broad, like yeah, in tilapia, of course, giant gourmet, and many other hosts are non-susceptible, but some of them are only carrier. And the fish can die without any clinical signs. And research is ongoing on this topic. But usually they display skin hemorrhages and erosion, and also pale and enlarged liver. For diagnosis, so usually brain and liver are most targeted organ for this virus. And again, histopathology, they display a generic typical viral infection with inclusion body as indication of viral replication inside the cell. And PCR, of course, this is the gold standard for diagnosis. So far, they have conventional PCR with nested PCR and also qPCR to identify this RNA virus. And for the cell line, now only E11 cell line known to be effective, permissible to multiply this virus. Another techniques, which is use immunological principle to identify the particle of this virus. And again, the same. So the global distribution, this virus has best been reported when you have tilapia culture in your country. So yeah, almost everywhere is newly emerging disease. And the next virus is infectious spleen and kidney necrosis virus. Yes, CNV. So this double-stranded DNA virus has a quite wide host range, or includes at least 39 marine fish and at least 10 freshwater fish species. So this virus can infect no matter the fish, marine or freshwater. So in this cladogram, you can see SKNV has 3 genotypes. So it's TRBRV, SKNV, and RSV. They're similar but different. And then SKNV infection is reported on new host and location every year. Like in Indonesia, recently they report this virus in giant gourami and bluegill sunfish in China and giant sea perch in Taiwan. Clinical signs: anorexia. So fish become skinny, they don't want to eat. And then sometimes you got hemorrhage on the surface of the body. So like this. So this virus also infect tilapia. So tilapia, yeah, has many viruses. Susceptible. And then discoloration of the heart and liver can be occurred, and enlargement of posterior and anterior kidney and also spleen. And recently, so this is part of my thesis research. So ESKNV displays a novel clinical signs. So fish become green. So throughout the body, very skinny, not eating, and become green. And yeah, this is interesting. So ESKNV can display very wide clinical sign. So this is totally new clinical sign for ESKNV infection. And then histopathology, ESKNV display typical viral infection with enlarged cell nuclei, and also okay, so this is interesting that this lesion in histopathology is sometimes not present or very difficult to observe. In a mass mortality case in Vietnam in Paramandi in 2017, even in mass mortality, no megalocytes, the lesion is called megalocytes, no megalocytes were reported during the mass mortality. So maybe the virus replicate and crosses the cell really quick, then no time for they create the inclusion body bearing cells. So it can be species specific for the SKNV lesion. And this is the electron micrograph in tilapia with the SKNV infection. Diagnosis, so first PCR, why I recommend conventional PCR to identify this virus. And Australia has its own method using more specific PCR, qPCR, and also TACMan. So Australia also declared free zone from this virus. And cell culture. So it's actually difficult to culture SKNV. So within a few passages, they will decrease quickly. And then also this virus can be identified, diagnosis using indirect fluorescent antibody test. With monoclonal antibody, you can see kind of fluorescent thing like this, specific for the variant of the virus. And distribution. So SKNV distribution is kind of spread around the world because this virus is spreading through ornamental fish trading. And this virus can also show subclinical infection. So healthy looking fish actually infected with this virus, then spread around the world. So this is part of my research, which is interesting. So knowing that SKNV spread through fish trading, ornamental fish trading. So so we try to apply a single polymorphism nucleotide analysis at genomic level. So using this, so we could identify the origin of the virus, so they kind of group together, which is very interesting. So we could identify the origin of this is a fish, in this case ornamental fish. Okay, so far there's no effective medication to cure viral infection in aquaculture. So the best way to manage the viral infection is prevention. So part of prevention is vaccination. So I will just like briefly talk about a vaccination here, kind of type of vaccine. So the first one is live attenuated virus and formalin gel vaccine. So this is the traditional way to make a vaccine. However, this is with this kind of technology, that's the only commercial vaccine available for aquaculture viruses. So like this one, KV3, this is the only commercial vaccine for KHV. And also Aquavac irido5, this is for iridoviruses. Actually, also they claim this one also effective for SKNV, but in reality, fish still died with the SKNV infection after vaccination. And then the second generation is recombinant protein vaccine. So briefly, we cannot select immunogenic gene, then insert into a plasmid and express into another expression host. So we could get protein, which is part of the immunogenic gene of the virus. And so we develop this recombinant protein vaccine for Coihortus virus. So we tested and using multiple administration methods, try the booster, and we found that the intramuscular injection is the best way to administer the vaccine and give protection up to 80%. Right, and then this is more advanced technology for vaccination. And this very interesting gastric vaccine developed by another group of by a group of scientists from China. So they develop a prebiotic bacteria which also produce a protein recombinant vaccine for KHV. The bacteria were then protected with a ketosane algae capsule. This is to make sure the vaccine can reach the fish intestine, so the lactobacillus can colonize the digestive system. So they choose their can targets and then insert the gene target into the lactobacillus. Then the lactobacillus will display KHV antigen here. So they check using the fluorescent assay. And then they cover the lactobacillus with chitosan alginate capsule to protect the vaccine. And the result is interesting. They can remain in digestive tract for at least 20 days and protected from digestion with high survival rate. Right. So the other prevention and control is biosecurity. So basically the principle of biosecurity is to restrict pathogen through entering the aquaculture facility and to restrict pathogen spreading within the aquaculture facility, and also restrict the pathogen to exit the aquaculture facility. So basically contain to restrict the spread of the pathogen. And the holistic effort is required to create effective biosecurity measures. So all farms in our area should use this biosecurity concept. If only 1 or 2 farms from say 10 in the area, so it will be not effective. The pathogen will still around, and yeah, the protection will be minimal.
Sorry.
Okay, so for the yes.
Yeah, I think we have already out of time.
Okay, so I will just conclude. So yeah, after this, so this is application of biosecurity measures which we have to follow for effective biosecurity. So for the conclusion, viral disease is one of major concern in aquaculture, and prevention is the best way to manage with viral disease, and proper biosecurity application needs to be applied in the holistic way for effective prevention. Some reference, and thank you.
Thank you very much, Dr. Takia. So to shorten the time for the questions, you can chat in the box and then we will discuss later after our next keynote speakers. So a big round of applause for Dr. Cahya. And for appreciation, we would like to show the certificate of appreciation to Dr. Cahya for his great talk today. Thank you very much, Dr. Cahya. And now we will continue to our next speaker. He is Professor Kato Yasuhiro from Keio University. So Professor Kato Yasuhiro graduated from the Nagoya University by Agricultural Sciences, and then he continued his postdoctoral in the Johns Hopkins University School of Medicine, which he was on the same team with Peter Egger, the scientist who won the Nobel of Chemistry in 2003 in discovery of aquaporin transporter. And in 2009, he continued as a Keio working in Keio University, and until now, he is one of the head leading researchers in Keio University, one of the top private universities in Japan, which is located in Tokyo. So, Prof. Kato, because we are running out of time, so we have a problem. Prof. Kato and Dr. Kim has another agenda on 14:30. So I am very sorry for a delay that I have to ask you to shorten your talk, Prof. Kato and Dr. Kim. So I would like to welcome Prof. Kato first to finish his talk, and then we continue with Dr. Kim. So Prof. Kato, the time is yours. Thank you very much.
Oh, okay, thank you. So sorry, and today is bad schedule, so I would like to do my presentation in the short way. Okay, I'm just sharing my. Could I see my presentation? Okay, so today I would like to talk about the. This is the skipping. So what is used as a biomarker for diagnosis? Mostly the scientists in the focusing in some solute. Like this is the schematic of the cells. But very important, water, because mostly the cell has water, about 70%. So Professor Chenkova, she established aquaphotomics. It means like here. So maybe water molecule mirror be used the biomarker for diagnosis. So how to visualize water molecule? That is important. I'm using near-infrared spectroscopy. And this one could be to get some vibration of the water, like this area. So I can next slide just showing the water has some like this kind of the vibration, and then each NL spectra discrimination of the different kind of the vibration and the water clustering. So I try to using this system to discrimination of the disease or some mineral water or something like that. So just fast conclusion, the solution to the construction is solute and solvent. But soluted is very volumy and so many kind of the soluted. So it's very infinity factor. But solvent is only water. The water is mirrored all information of the salt. So today just to talk about solutes and solvent interaction could be detecting by water molecule vibration by using the near infrared. Near future that can be using for the this biomarker for detecting some disease or like. So I just introduced the clinical information. I just skip. This is low spectral data, and then we can try to use some mathematical method like PCS or something like. And PCA is very most important, the discrimination of something like. This is the schematic of some meaning of the PCA. It means mostly the spectral data is very huge of the data. So that's one the more smallest and visualize some multiplicative data by using some score and loading code. So here is just one of the results. This is, I try to discrimination of the different kind of the mineral water. Different color means some different various water. And this line is indicated some depend on the temperature. So how to discrimination of each water can be this one. Be just some water vibration and some class 1, 2, 3, 4. It's very important discrimination of each kind of the water. So the vibration with the water is very useful for discrimination. So that is first result is in my side. So this one is already publication in the applied science last year. So, and another focusing, I'm just trying to detecting oxidative stress in the body, because the oxidative stress cause some disease and related some aging. So in my case, or just the glutathione is very important, some nervous, some disease and some like this kind of the neural some disease and Alzheimer's disease is very important, the glutathione concentration, and also circadian rhythm also regulated some glutathione construction. So now try to differentiate some different kind of the oxidase and reducing some glutathione by using discrimination with the glutathione type by using some near-infrared spectroscopy. So I try to, because some soybean and also seaweed is very important to the healthy food. It's both case of the very high antioxidant function, but protein level is very different. And then also seaweed can be growing on the seawater. Also, this spirulina is one kind of the seaweed. There has high antioxidant activity compared to another control some seaweed. Also, collagen is very important anti-aging. Also, spirulina has some high contents compared to another seaweed. And also, this spirulina has more good extraction. So like recently is very important, some virus infection of some disease. Mostly the virus bind into the membrane, but some sulfate from the spirulina can be protect them to attaching some the cell membrane. So maybe this kind of product to apply to some lipstick or some staining of the blue. This is one of the very popular ice cream in Japan. So I try to visualize water pattern contributed extent in healthy condition or some quality control of water by using near-infrared spectroscopy. So I try to applying some establish this kind of the system. Thank you.
Okay, Professor Kato Sensei, sorry very much for rushing you in your very shortened time. So for Kato Sensei's discussion, we would have to postpone also Kato Sensei, but I welcome for participants, if you would like to ask questions, please chat in the box and then we will direct, or if Kato Sensei would directly answer and then.
Okay, later I can, anytime is okay. Thank you.
Yeah. Yeah, and we wait for you to come to Lombok again, Kato Sensei.
Yeah, oh, every time. Also, Eka Sensei, please come to Japan. Yeah, thank you. Thank you so much invitation.
Thank you very much. So big round of applause for Professor Kato. And we would also like to show the certificate of appreciation to Prof. Kato. Thank you very much for your inspiring talk today, Kato Sensei. And once again, I apologize for the time schedule that we have to delay our meeting this week.
Okay.
So for the next speaker, I would like to welcome Dr. Kim Lee Chang he is a senior researcher from CSIRO Oceans and Atmosphere in Australia. He graduated his PhD from the University of Tasmania. And until now, he's working on microalgae. And today he would like to share his work on what he is doing in what he's working in CSIRO for microalgae utilization. So Dr. Kim, I would welcome you to share your presentation. Thank you very much.
Thank you, Dr. Eka. Thanks for the organizing committee for inviting me for the talk. Yeah, I'd like to start by acknowledge the Miwina people, the people from the land that I'm speaking from, and pay my respect to the elders past and present. So today I'd like to talk about the alternative source of sustainable omega-3 oil from the sea. So this is where we're from, and as you can see, we are at the northern part of Australia, from a small island. And I work very closely with the National Culture Collection. So we have about 1,000 different strains, 300 different species of microalgae and macroalgae, from tropical to temperate to even to Antarctic. So why microalgae is really the rich source of biodiversity, and it's very good source of protein, lipid, and other byproduct. For example, the polysaccharide and pigments. And also the one thing to point out is, microalgae can consume about 1.5 tons of carbon dioxide to produce every ton of biomass. So it's a very good carbon capture and reduce the greenhouse gases emission. So as you can see here, this is a tree of life, and the biodiversity of the microalgae is huge. So the circle is where the plants and animal is, but the rest of the algae is just distributed around the different. So, and we know the algae biomass can produce a lot of different bioactive compounds. For example, the lipid, the carbohydrate, and the proteins. And you've probably seen this before. And the main point of this talk is omega-3 oil. So at CSIRO, we have a different team working on different products. For example, the Norway prawn feed. And we also work on the omega-3 oils added to the livestock feed to increase the omega-3 oils on the animal and the meat. I will show more about different examples of the work that we have done. So in terms of growing microalgae, there's different cultivation system. We have the upper pond and the bioreactor. And as you can see, the biggest open pond system in the Australia is the pink lake. You always see the nice picture of the pink lake from they're growing the Danella, the hypersaline microalgae to making beta carotene. So at the bottom, you can see different bioreactor we can also use for fermentation, like heterotrophic growth of different algae or microbes. I'm going to talk more about it. However, the scale up challenge for open pond is very dilute and lots of water. So almost 80% is water, and the biomass is, as you can see here, only 0.2 gram per liter per day. And the challenge is really harvesting the water for the dilute culture. And this graph is really show, some of the work that we have done screening the different composition in the algae collection. As you can see, the orange bar here is a protein content. The purple is a carbohydrate, and the lipid is the blue one. Just to give you a taste of under unoptimized condition, what sort of composition they have. And this is just to show you different seaweed, macroalgae, different species of it. We have screened about 60 different seaweed. And as you can see, they have very nice fatty acid profile. Almost up to 60% of the lipid is PUFA, polyunsaturated fatty acid. However, their total fatty acid is very low. And this is another piece of work that we have done is by putting the gene from microalgae to canola plant. So it's a partnership between CSIRO, New Seed, and the GRDC. And this had been done almost 20 years ago. So now have been approved because it's a GM crop. So they have been putting up to 6 to 7 genes from microalgae selected from the culture collection and engineered into the canola plant. And we also have others algae research activity. For example, for myself, we're using different algae to try to improve the health of the salmon and the prawn. And also this is another heterotrophic growth. We start from biodiscovery, find the microbes. This is one of my favorite. We call it Trochochycid. It's really a protist. They're very similar to algae. They're more like a fungi. But we can, grow in the fermenter and give us a very good profile. And we have been partnership with different companies to even put in the infant formula and the fish oil, as you can see here. So this is one of the company that we partner with, PharmaMark. So we have been working on strength optimization and scale up the production. I didn't mention that, fish don't make fish oil. Fish eating the microalgae accumulate on their body to produce the fish oil. So we bypass the fish and we can have a vegetarian or vegan source of omega-3, and that's like free from pollutant. So in summary, algae technologies are not really universal applicable. It's different species require different way to grow them. Also, the advance in biotechnology are really need to develop sharp technology. So I just want to acknowledge different team member that work on the different part of the project. And thank you.
Thank you very much, Dr. Kim. I'm not sure, do you have time to receive any questions?
Yeah, I can take any question from, yeah.
So please, if anyone wants to ask Dr. Kim and probably Prof. Kato any questions, I'll welcome you now, because Dr. Kim also have to go. He has another agenda. Is there any questions for Dr. Kim? Probably I would just like to ask Dr. Kim, for the macroalgae, have you ever investigated any macroalgae which is from the Indonesian coastal areas?
No, actually. So, we just, my work have been, focused on the endemic Australian strains. So, we work because, as you know, Australian have very high biosecurity. So we always try to use what we have. But, definitely room for cooperation there. Yeah.
Yeah. If in the future we can work together because I think the macroalgae potential in Indonesia is, especially in Western South Tenggara province, is still very limited information in that area, Dr. Kim.
Correct.
Any more questions? From the offline audiences? Okay, if there are any no more questions, I would like the audience to give a big round of applause to Dr. Kim for his presentation today. Thank you very much, Dr. Kim, for joining us today. I'm very sorry to get the schedule messed up for today's meeting. And hopefully in the future, we can discuss and have a much more longer time for a much more deeper discussion.
Thank you.
Thank you very much, Dr. Kim. So for the last speaker, but not the least, is actually a very, how do you say it? He has lots of publications and in a very young age. Is Dr. Munawar Halil. Is Dr. Munawar Halil here result? Okay, he's already on. So he was actually my senior during my master studies in University of Malaya. And then he finished his bachelor degree in ICBB University and master's in University of Malaya, and then continued to get his PhD in New Mexico, USA. So for publications, he already has 80 documents in more than 1,000 citations already in such a young age. Now he is previously he was the Deputy Director of Research Collaboration in University of Indonesia. Now he's the Director of Research and Development in University of Indonesia. So Dr. Halil, please, the time is yours please start your presentation. Thank you very much.
Okay, right. Thank you, Dr. Eka. So as everyone can see my slides and hear my voice clearly. Hello? Hello? Is everyone hear my? Okay, right. Okay. So it's right. Thank you very much, Dr. Eka, for the very nice introduction. So first of all, I would like to gratefully acknowledge Universitas Mataram, especially the organizing committee for the 5th International Conference on Bioscience and Biotechnology 2022 for inviting me to share just a little bit on the potential applications of marine products for the synthesis of advanced nanomaterials. So today, what I'm going to share with you, I would like to begin my presentations by highlighting the current shift of paradigm that has been going on for the past couple of years due to the advancement of nanotechnology. So as we all know together, traditionally people used to build something big in associations with their accomplishments. For example, in the past, people built the pyramids, you know, the Taj Mahal, Colosseum, things like that, to mark their legacies. But now, with the advancement of technology, the paradigm is shifted. Not only the success of a technology, not only considered by the ability to build something big, but also to build something very, very small. For example, people nowadays can fabricate a very, very small nano chips, which is why if you remember, our phone used to be very big, right? And now it's you know, getting smaller and smaller, flexibles. We were able to fabricate nano robotics that can go inside your body, and a very efficient solar cells, for example, that we require a very big area. So now it can deposit it in a very small areas with a pretty much the same efficiency. So the keywords is really small is the new big. So that is why at Universitas Indonesia, our work has been focusing on the rational design of low-dimensional functional materials with specific applications in different areas, including catalysis, renewable energy, biomedical electronics, sensing devices, oil and gas industry, as well as we also several type of nanomaterials for energy storage. So here are some of the examples of nanoparticles or nanomaterial that we have been synthesized at our lab with different morphologies. We have developed different type of synthetic protocols to make different type of nanoparticles, such as metal nanoparticle, metal oxides, semiconductors, perovskites, you know, quantum dots nanoparticles, with high control in shape. As you can see, we were able to make, for example, titanium dioxide, a very well-known photocatalysis in different shapes, octahedrals, sheets, nanospindle, things like that, as well as gold nanoparticles in the form of gold nanocubes, nanorods, nanosphere, which is currently one of the hot materials applied in biomedical applications, especially for drug delivery. And we have also used these materials in various applications. Here are some of our examples of applications where we use different type of nanoparticles for the reductions of carbonate into value-added chemicals, photocatalytic fuel cells, and biomedical applications and drug delivery as well. In fact, we have a joint publication with Dr. Ekta recently at the RC Advances, where iron oxide nanoparticles used as an efficient targeted drug delivery, anti-cancer drug delivery. But the one that I would like to share with you today is the potential applications of marine products for the green synthesis of nanomaterials. So basically, when it comes to the methods of nanoparticle synthesis, we can divide it into three major types, depending on how the nanoparticle is being fabricated. Number one is chemical synthesis. This is the most common one, where the nanoparticles precursors, usually in the form of metal salt, is reacted through reduction reactions with reducing agents to form the metal or metal oxide nanoparticles. The second one is the physical method. Usually in this method, the nanoparticles are fabricated through a top-down approach. So in general, there are two categories of nanoparticle synthesis: bottom-up and top-down. Chemical synthesis and biological synthesis is sometimes considered as the bottom-up, and physical method is considered as a top-down. So you start it with something big and then expose it to high energy laser ablation to form a smaller pieces of metal nanoparticles. So that's one of the things, one of the ways for you to fabricate nanoparticles. And for today, I would like to emphasize the third method, the biological synthesis method, where we use the extract of biological entities, for example, plants, including marine products, as both reducing agent and capping agent to make nanoparticles. So typically in this biological synthesis, or sometimes it's also known as green synthesis, because we started with plant extract. The plant, the secondary metabolite is extracted from the plant through different type of extraction method, for example, through shock slugs, percolations, maceration, and things like that, and use the plant extract as the one of the materials to synthesize the nanoparticles and combine with the metal precursors. So in the same fashion's way, we can definitely use marine product, for example, seaweeds and algae, as the source of metabolites, secondary metabolites for the synthesis of nanoparticles. Now, why marine product is very promoting potential in the synthesis of nanoparticles, and what is the main benefits of using extract from marine products for the synthesis of nanoparticles. So when it comes down to the mechanisms of nanoparticle synthesis, according to the Lemaire's theory, the formations or the crystal growth of nanoparticles can be divided into 3 stages. Number 1 is the nucleations, the supersaturations of the monomers, where the ions from the metal precursors being reduced into the metal. So when the concentrations of the monomers reach above the concentrations of saturations, the seeds for the crystal growth start to appear. This stage is often called the burst nucleations. This is the second stage in the nanoparticle synthesis. And next, once the seed nanoparticles become larger and larger, it will grow into the final stage of the nanoparticles that we are going to obtain from the process. Now, if we look at and pay attention to the third stage, which is the control growth towards controlled growth of the nanoparticles, we can basically manipulate the shape and morphology of the nanoparticles by introducing what we call as a capping agent, which can selectively bind to the specific type of crystal facets and prevent the crystal growth in that directions. So as the result, we can have different nanoparticles with various shapes and morphology. Here, you can see an illustrations where a nanoparticle is growing without and with capping agent that binds at different crystal facets. The red one is the capping agent that has the ability to bind at 111 crystal facets. As the result, we are going to end up with a cube-like structure. Meanwhile, if we introduce a capping agent that has the ability to bind more intensely at the 100 crystal facet, we will end up with a nano-octahedral nanoparticle. So by selecting a suitable or selective capping agent, we are going to able to control which shape or size of the particle that we're going to have. And if you look at in the literatures, there have been different type of capping agent that been used in the synthesis of the different type of nanoparticles. So based on the type of the capping agent, it can be categorized as surfactants. So here, as you can see, the cetyl 3-methyl ammonium bromide is one of the most well-known capping agent in synthesis of nanoparticles, especially gold nanoparticles, for example. Amino acids, polymers have been used widely as the capping agent as well. PEG, PPV, and many other polymers. And more importantly, as you can see here, several type of secondary metabolites, which naturally abundant and can be obtained from marine products, can also be used as a capping agent here, which is the polysaccharides. So with different type of polysaccharides and metabolites secondary from marine products, we can definitely use them to control the synthesis of nanoparticles to direct it to form our desired shape and morphology. Why do we have to control the size and morphology of the nanoparticle? So here some of the examples on how important crystal facet engineering or controlling the shape and morphology of nanoparticles to its applications. So I show you here, for examples, for the in the development of photocatalytic materials, for example, by having a main control in crystal facets or shapes and morphology of the nanoparticles, we can at least have three benefits. One, we can, by exposing this specific crystal facet in our nanoparticles, we can control the absorptions of the reactants. So for example, we would like to facilitate one typical reactions or one specific substrate, we can select which crystal facet that is being exposed. Secondly, it is also reported that by controlling the shape of the nanoparticles, at the same time controlling the facet of the crystal, can also be used to fine-tune the electronic properties of the materials. Typically, people are using doping approach, for example, excuse me, by introducing foreign atoms to the crystal. But this technique is often changing the whole characteristic of the materials. Therefore, I think by exposing certain type of crystal facets, we can definitely fine-tune the crystal, the electronic properties of the material, for example, the band gap of the materials. And thirdly, we can also use the different crystal facets as the host or the reservoir for the photogenerated electrons. This is important when it comes to photocatalytic materials, because the one that can facilitate the reactions, the redox reactions, is the photogenerated holes and electrons. So by having materials that have exposed a certain type of crystal facets, we can actually reduce the rate of recombinations between electrons and protons. Okay, so in the next few slides, I will try to show you the current advancement on different the applications of different marine products and the applications of their extract in the nanoparticle synthesis. So here are some of the tabulations of green synthesis of two different type of nanomaterials, silver nanoparticles and gold nanoparticles, using different type of marine products or microalgae. So as you can see here, with different type of microalgae, we can get different type of both silver and gold nanoparticles shape and morphology as well as size. This is partly because, as I mentioned earlier, that each different marine products have different content compositions of secondary metabolites, where it can have different roles in, directing the crystal growth into specific morphologies. For example, if you would like to fabricate silver nanoparticles with a small spherical morphology, you can use the extract from Chlorococcum fumicola, for example. But instead, if you would like to synthesize silver nanocubes over here, definitely you can use Botryococcus browni microalgae. So because these two microalgae has different secondary metabolites contents, it will direct your crystal growth into different directions. And as the result, you will end up with different shape of nanoparticles. The same thing with gold nanoparticles. So if you like to get a spherical nanoparticles, you can either use Tetraselmis or Cystoceira baccata microalgae. But if you like to, have a pseudo-spherical or triangle type of gold nanoparticles, you can use different type of algae, for example, Turbinaria conoides. So that's some of the examples on how the biodiversity or the secondary metabolites content in marine products can influence the shape of the nanoparticles. So in the next few slides, I will show you how the shape of nanoparticles originated from different type of marine products extract can influence not only the size and shape and morphology of nanoparticles, but also it can influence the performance of the nanoparticle when it applies at different field of different applications. So here, one of the examples, recent publications here reported by Princey and Gopinath. They synthesize silver nanoparticles. You can see it's a very nice spherical nanoparticles here with the size, the average size around 19.3 nanometers, where they use the extract from seaweed called Fucus gardiner from Norway, and use the nanoparticles as the catalyst for the reductions of 4-nitrophenol. And as you can see here on the result, the nanoparticles, the silver nanoparticles synthesized using the seaweed's extract showed an excellent ability and kinetics in terms of facilitating the reductions of 4-nitrophenol. Even though, even compared with other nanoparticles synthesized with plant extracts or using other methods. So that's one of the benefits that we can get. It may or may not be originated from the size and shape of the morphology of nanoparticles, but also it can also be caused by some of the capping agent that is still attached on the surface of the simple nanoparticles as the remnants from the extracts of the seaweeds. So here is another nice example on how secondary metabolites from seaweed extract, in this case, Halimania dilatata, or commonly called as the dragon's tongue, for the synthesis of gold nanoparticles. So previously it was silver nanoparticles, now it's gold nanoparticles, and how it can help the gold nanoparticles to exhibit a more or better performance as antioxidant, anti-cancers, and antibacterial activities. So as you can see here, the synthesis using the seaweed extract can render very nice polyhedral nanoparticles with the size of the average of around 50 to 20 nanometers. And it showed an excellent or promising abilities as the anti-cancers for the ST21 cancer cell, with a very nice looking cytotoxicity test result, as well as good antibacterial activity, and it is reported to have a non-toxic against health cell, proven by the phase embryo toxicity test. So here is another example of the applications of other type of seaweed extract. Now is for the application, is for the synthesis of mixed oxides. So previously, the previous two was for the synthesis of metal nanoparticles. So now is the metal oxide nanoparticles. So and showed that the here the materials is copper ferrite, cobalt ferrite nanoparticles, and it shows a very promising ability to facilitate oxygen evolution reactions. Here I show you another examples reported in the scientific reports recently, where 3 types of algae can be used to synthesize silver nanoparticles, which can be used as anti-cancer agent and antibacterial agent against a different type of pathogenic bacteria here. So I think here another examples, the utilizations of marine algae extract to synthesize metal oxide nanoparticles, in this case zinc oxide. Here is the image of the nanoparticles obtained from the synthesis using the extract of Tetraselmis indica, where it showed a very promising antibacterial activity against E. coli and aureus, as well as a nice ability to facilitate the antioxidant activity. So to conclude this presentation, so a couple points I would like to summarize. First, green synthesis using marine products such as seaweeds and algae holds a tremendous potential for large-scale productions, because I think we can also hear from Dr. Kim's presentations previously that, you know, in terms of the availability and abundance, algae or seaweed has a very has a very potential benefits against different type of plant extract. So it can be used for large-scale production, so, for the publication of different type of low-dimensional advanced nanomaterials. Rich and diverse secondary metabolites in seaweeds or algae, and rich biodiversity in Indonesia probably could serve as both reducing agent and capping agents to direct the formations of nanomaterials. So I think this is one of the potential avenue for research where, you know, different type of marine products or seaweeds or algae can be used to form different nanomaterials with different morphology. So therefore, different type of marine products will typically render to different shape morphology and leading to a new and unique physicochemical properties. As the result, in most cases, based on the report that has been published during past couple of years, nanomaterials that are synthesized using marine products tend to exhibit better performance in various applications, as we have seen as well in the slides. For example, it would give us better catalytic activity, anti-cancer activity, antioxidant, antibacterial activities. So that's probably that I would like to that I can share. Thank you very much for your attentions and invitations. I give the floor back to moderator Dr. Eka. Terima kasih. Thank you very much.
Thank you very much, Dr. Munawar Khalil. It's a very interesting work that you just presented to us. But before discussions for Dr. Khalil, I think we have to ask Dr. Chahya, because I'm not sure what time is it in the US. Dr. Chahya is still with us?
Yes.
Dr. Chahya?
No, it's 3 a.m. here.
This is so it's 3 a.m. now. Okay. So there's one question for Dr. Chahya from Dr. Alice Bolis. So did you read it already?
Yes,
Among the
I think
methods
I have answered it too. I just typed it there.
Oh,
But,
okay.
Yeah.
Yeah. Also, Dr. Mulis asked, among the methods of virus control in aquaculture that have been described, in your understanding, which method has been applied by the aquaculture industry, or probably in Indonesia? And is it going well, or are there many problems about this?
Okay. So first for the vaccination, at the moment, the commercially available vaccine, I think mostly they use the traditional way, which is inactive virus or bacteria or live attenuated vaccines. While the recent technology usually just stop at a laboratory level for some reason, like they have to pass safety like analysis. This is mostly regarding to the effect of the vaccine to the environment, to the other organism or something else. If the vaccine just released unintentionally to the environment. So yeah, Indonesia, not much, because not many commercial vaccine available in aquaculture, to be honest. And for the biosecurity, again, in developed countries, it's kind of compulsory to have biosecurity plan for aquaculture facilities. But in the developing country, that such thing can cost quite high. Therefore, and it's also not compulsory, and that makes application of biosecurity in developing country, including Indonesia, it's very minimal. So yeah, it's almost nothing. And to be honest, research in this field is also very few. Yeah, like maybe simple research like not simple but important disinfection protocols to inactivate the virus. That's also only very few. I think it's important to know to develop a cheap applicable method to disinfect any certain virus. Yeah, but not much research on this field. Yeah, I think that's for me.
Thank you. Did ask the question, Dr. Wallace? Any more questions for Dr. Chaya? Any more questions? Okay. I think someone raised their hand in the back.
Yeah, thank you very much, Dr. Cahya. I want to ask you about how long does it take for fish to survive after being infected with tilapia virus? And the second question: what is the impact if consuming fish that has been infected with tilapia virus on the human body? Terima kasih. Thank you.
Well, thank you. For the first question, so it really depends on the fish immunity. So the mortality can up to 90% within a population only in a week. So the survivor can develop immunity and they can survive, but we don't know yet if the usually virus infection is very related to the optimal temperature. So if maybe in the future the temperature is again suitable for the virus to replicate, probably they will have this kind of a second outbreak even for the survivor. But yeah, research is still going on here. And then so far, no zoonosis report from viral disease in fish to the human. So far it's safe to consume fish with virus disease. But usually when a fish get a virus infected, they will die. And yeah, nobody want to eat died fish. So yeah, it's not common to eat died fish because of viral infection. But so far, no report of zoonosis or infection of a fish of virus could infect human. Yeah, so it's better you cook your fish properly. It will, I can say, safer. Yeah. Thank you.
Thank you very much, Dr. Chaya, for the answer. Did that answer the question? Okay. Yep, probably I would like to welcome any other questions for Dr. Chahya. Okay.
That's okay. Thank you for the opportunity. Dr. Cahya, I want to ask you something about tilapia lake virus from Israel. Let me introduce myself. My name is Andy, and I want to ask you about tilapia lake virus from Israel. In your slide, you show to us the distribution map of this tilapia virus, but there is no one country near Israel infected by that virus, but there is so far country from Israel can be infected by that virus. is human activity also one of the cause because infected by this virus? I think that's all my question. Thank you for your opportunity.
Okay, actually, maybe Israel is too small compared to be visualized in the map, but yeah, if you can check the publication, so it's from Surat Setpong et al. 2020. Yeah, about tilapia lake virus. So yeah, Israel is there. If you wanna see, if you wanna zoom the map, yeah, it's there. And about the human activity, I'm not sure, but yeah, probably the spreading of the virus can be because of the human activity, disrespect the biosecurity, or they introduce infected fish to the new environment. Yeah, it can be. Yeah, but I'm not sure, but that one possibility. It just happens, and yeah, we don't know.
That answers the question. Yeah. Thank you very much, Dr. Chahya, for your nice presentation. So for further discussions, if you want to contact Dr. Chahya, probably Dr. Chahya is willing to share his email. I'm not sure. So Dr. Chahya, thank you very much. I will move on to the questions for Dr. Munawar Halil. Is there any questions? Okay, we have one question from the offline audience for Dr. Halil.
Thank you very much for the opportunity. My question addressed to Dr. Munawar Halil. From the presentation, there are three types to generate a nanoparticle, such as a chemical method, chemical, physical, and biological. Could you explain the strength and weakness from that three methods? Which one the best method to produce the nanomaterial? This is just my question. Thank you very much.
Okay, thank you very much. I forget, I don't recall the name, so probably I'll just like answer anyway. Yes, you're correct. There are three types of ways to fabricate the nanoparticles, so chemical, physical, and biological synthesis. Each method has their own benefits and disadvantages. So I think it really depends on the goal that you want to achieve. For example, if you want to produce for large scale productions, for example, probably we will go with physical method because it's easier and it doesn't require any long synthetic routes. But if you want to get a very precise size, for example, that your nanoparticle has to be exactly in the range of 10 to 15 nanometers, then you can, the best way to fabricate it is through the chemical synthesis, because you will have the highest control in the synthesis, not like other type of synthesis, the physical and biological. But if you want to be cheap, for example, you can definitely use the biological, because it comes from the natural products, and what you have to do is just to get the extract of the plants, for example, of marine products, and doesn't really care about the size or shape. But what I just showed you just now is that even though biological is considered as the least common method to synthesize particles, but with the rich biodiversity of marine products that we have, where it can have different compositions of secondary metabolites, which intends to be rendering different type of nanoparticles with different morphologies. So I cannot really give you a very exact answers which one is which, so which one is the best one, but it really depends on the goals that you want to achieve. Whether you want to be economy, you want to be economics, you want to be fast, or you want to have a high control in the synthesis. So that's probably the way it is. So you really typically do not compare each one of it. So it really depends on your applications. I hope this answers your questions.
You want to comment on Dr. Hali's answer? Okay, she wants to comment.
Yep.
I think.
Maaf, boleh dalam bahasa Indonesia?
Boleh, silakan.
Ini presentasi yang sangat menarik. Saya kebetulan pertama kali mendengar istilah tentang sintesis nanopartikel. Ini kan mungkin pertanyaan saya sangat mendasar karena baru mengenal istilah ini. Nanopartikel sendiri kan tadi pengaplikasiannya pada bidang medis itu sebagai anti kanker, antioksidan. Nah, maksudnya nanopartikel itu bagaimana cara pengaplikasiannya sebagai anti kanker? Misalnya di lain hal, kalau kita mempunyai ekstrak itu kan langsung diaplikasikan kepada suatu misal HeLa sel sebagai anti kanker pengujiannya. Nah ini apa perbedaannya dengan ekstrak? Apakah dia makin kecil, makin bagus, apa seperti apa, Pak? Mohon penjelasannya. Terima kasih.
Ya, baik. Do you want me to answer you in English or bahasa Indonesia?
I think you can just use bahasa Indonesia.
Oke, baik. Terima kasih atas pertanyaannya. So I apologize for those who are not speaking Indonesian. So I'm gonna answer the question in bahasa Indonesia. Jadi untuk spesifik aplikasi biomedis sebenarnya macam-macam ya. Jadi untuk anti kanker dia bisa si nanopartikelnya itu sendiri mempunyai sifat anti kanker, jadi dia bisa membunuh sel kanker tersebut. Mekanismenya bisa macam-macam ya, bisa dia mengenerate reactive oxygen species gitu ya, kemudian atau mungkin dia menginhibit enzim tertentu sehingga sel kankernya menjadi mati. Nah, sama seperti ekstrak juga atau obat yang lain. Jadi obat yang lain juga punya berbagai macam cara untuk membunuh sel kanker. Ada yang menyerang DNA-nya, ada yang menyerang organel yang lain tadi macam-macam ya. Tapi kebanyakan atau yang mengenerate heat gitu ya, itu yang terapi hyperthermia namanya, itu menggunakan iron oxide nanoparticles, itu dia menggunakan sumber panas. Jadi nanopartikel disuntikan ke dalam tubuh lewat kemoterapi, masuk ke dalam sel kanker, kemudian diberikan radiasi sehingga sel kankernya menjadi mati. Itu banyak caranya. Itu satu cara, satu pendekatan bagaimana nanopartikel bisa berfungsi sebagai anti kanker. Yang kedua, nanopartikel juga bisa dipakai sebagai delivery. Ya, jadi agen untuk menghantarkan obatnya ke sel kankernya. Nah, kekurangan dari kemoterapi atau pemberian obat gitu ya. Jadi obat itu racun sebenarnya yang diberikan kepada pasien, tetapi dia tidak hanya menyerang sel kanker, tapi juga menyerang sel sehat. Jadi dia secara sporadik menyerang membunuh sel tidak hanya sel kanker, tapi sel sehat juga. Makanya biasanya kalau orang kemoterapi ada efek sampingnya ya, rambutnya rontok segala macam, itu karena obat yang diberikan juga menyerang sel sehat. Nah, nanopartikel bisa digunakan untuk mengantarkan obat tersebut spesifik hanya ke sel kanker saja. Jadi dia tidak membunuh sel sehatnya. Nah, itu yang kami lakukan dengan Dr. Eka sebenarnya ya, di salah satu publikasi kami menggunakan nanopartikel yang ditempelin oleh obat, kemudian obat ini bisa diarahkan ke target sel kanker saja, sehingga dia tidak membunuh sel-sel yang lain. Jadi apa namanya, bisa dia sendiri, intinya bisa dia sendiri mempunyai sifat sebagai anti kanker seperti silver nanopartikel, ya, nanopartikel perak, gold nanopartikel, atau iron oxide nanopartikel, atau dia juga bisa bersifat sebagai penghantar obat. Seperti itu mungkin.
Silakan dikomentari apa sudah menjawab. Okay, thank you very much, Dr. Munawar Halil, for the comprehensive answer. I think Prof. Sulaiman wants to comment.
Yeah, thank you, Dr. Eka. Yes, thank you very much, Dr. Munawar Halil, for your great presentation, especially the last thing that you explained in Indonesian. I think it's very clear for us, hopefully. Yeah, but for me, for myself, because I just as a user for the nanoparticle for development of immunodiagnostic, for example.
Yeah.
So I just thinking that for the future, the green synthesis of low dimension nanomaterial is very important for us, especially with our nature, great resources for example. Yeah, as you explained before, that might be economically when we use the green synthesis for huge or big product, I think still take times to us. But for myself, I think that's really promising. Yeah, what you explained to us in regard to synthesis low dimension nanomaterials in the future. Yep, I think that my comments for the presentation for today. Yep, thank you.
Hello. So yeah, Prof. Sulaiman was working with immunodiagnostics. One of his products with his team with Prof. Dr. Mulyanto was development of the rapid test for the SARS-CoV-2 virus previously used in 2021, I think. Yeah, the 2021. So have you ever looked into some research which could implement these green synthesis nanoparticles for application in immunodiagnostics?
Right.
Dr. Munawar
Yes.
Halil?
Definitely. Nanoparticle has been used widely in the fabrications of diagnostics, not only through immunotesting, but also in different type of sensing method, electrochemicals, for example, and things like that. I think some of the works that I know from the Faculty of Medicine at Universitas Indonesia, we also there's some researchers developing a testing kit for dengue viruses and things like that. They use gold nanoparticle as well. I also use some of my nanoparticles, not specifically for the detections of virus, but small molecules, uric acids. So I'll have a collaborations with ICBB Bogor, Institute Pertanian Bogor, to develop rapid testing for uric acid determination and nitrates in corn meal. So we use gold nanoparticles in graphene oxide. So I think you are very correct, Prof. Sulaiman, and I think this is a very great opportunity. Currently, the fabrication of nanoparticle is still using the chemical synthesis, where we use pure compounds, for example, as the capping agent. CTAP, SDS, and things like or polymers. But in the future, I think with the resources that we have, both in marine production or the plants or metabolic secondaries from plants can also be considered as an alternative for the synthesis when we're talking about large scale applications, for example. So definitely, I agree with you in this regard. Thank you very much.
Thank you very much, Dr. Munawar Halil. So, any more questions from the floor? I think there's no questions from online audience also. Any more questions for Dr. Munawar Halil and Dr. Cahya? Dr. Zainal, you want to comment on Dr. Cahya? Okay.
Because Professor Sulaiman gave a comment about the last presenter, so I will give a comment for the first presenter about the disease in the aquaculture. So yes, that the aquaculture production increased year by year, but it's the normal consequence that the fish disease in aquaculture also increased. Not only the increasing not only about the number of fish, but also the kind of the disease itself. But don't worry, because the presenter also say about there is a lot of kind of the disease diagnosis to identify the disease, and including like vaccination and apply the biosecurity, and maybe in the next, like nanoparticle also can be used to face disease in aquaculture. Thank you very much.
Oh, very nice comment, Dr. Zainal. Do you want to comment on that, Dr. Munawar Halil or Dr. Cahya? I'm actually not sure about the application of nanoparticles. Is it only focused on biomedical applications, or is there a much broader application probably in feedstocks, or maybe I think one interesting is for bioremediation, for cleansing of the. I'm not sure if we have a want to clean some toxicants from some environment. Is there any applications to the area?
Well, actually, when it comes to the application of nanoparticles, people said really the sky is the limit. So I think there is no limitations on as long as we have not imagined previously that nanoparticles can be applied in a biomedical application, and now we see that many commercial products has been derived from nanomaterials. So when it, regarding the concerns of environment effects of the nanoparticles, I think that should not be an issue as well, because many nanoparticle is biocompatible. For example, gold nanoparticle is known to be non-toxic at all. You can eat gold basically, or iron oxide has no environment effects at all to the both in humans or in the natures. As long as the type, it really depends on the type of the nanoparticles. Of course, if you're using like a heavy metal nanoparticles, like platinum nanoparticles, or palladium nanoparticles, or lead nanoparticles, of course it will have any environmental impacts. But when it comes to certain type of nanoparticles, you can definitely select the one that biocompatible. I think that's probably my comments on that.
Is there any industries in Indonesia which already use these nanoparticles as their technology?
Yeah, there are a couple of startups. I heard that some, in Medan they synthesize them. There's a startup in Medan. I think it's one of our friends as well. It's an alumni from Taiwan universities, and going back to the PhD in Taiwan, and going back to Medan and build a startup that's specialized in synthesizing nanoparticles and sell it. So even though it's done in a large scale, so I think you can sell in a few grams or few milliliters like that. You can find it in Tokopedia.
I didn't think that we could find nanoparticles in Tokopedia, so it's quite.
You do.
So, any more comments? Okay, so I think there are no more questions. So if you would like to have any more questions, you could just directly contact the keynote speakers. And I would like to confirm, is it okay? Probably I will, the committee will contact you later if it's possible to share the presentation materials, but yeah, that will be maybe after this session. So let's give a big round of applause for our presenter in keynote session 2. And hopefully in the future we could we are waiting for you to visit Lombok for Dr. Chahya and Dr. Munawar Halil. So with this, this is the end of the keynote session 2. Thank you very much for your attention. I would like to return to the moderator of MC, Ms. Hilda.
Thank you very much, all the keynote speakers, Dr. Cahaya Kurnia, and then Dr. Kim Lee Chang, Associate Professor Kato Yasuhiro, and Dr. Munawar Khalil. And of course, thank you very much, Dr. Eka, for leading the session. What a great discussion, and also very informative and interesting presentation from our keynote speakers today. Ladies and gentlemen, for the next session, all of you are welcome to have coffee break outside the room. And after the break, you can proceed to poster session in this room. And this session will start promptly after the coffee break at 4 a.m. So please have the coffee break. Thank you. Bagi para partisipan yang memiliki poster yang akan ditampilkan pada poster session, kami mohon kesediaannya untuk mungkin nanti standby di samping poster masing-masing. Jadi posternya akan ditampilkan di layar yang ada di depan, dan in case ada yang ingin bertanya terkait dengan riset yang ditampilkan di poster, maka akan mohon kesediaan dari partisipan, khususnya poster presenter, untuk berdiri atau standby di dekat poster masing-masing. Terima kasih. Bapak Ibu yang ingin mengambil atau menikmati ala kadarnya, hidangan kami sudah tersedia di luar. Jadi silakan menikmati coffee break-nya. Dan selanjutnya untuk poster session, kami mohon kesediaan Bapak Ibu untuk hadir di tempat nanti karena kami akan meminta ya seluruh partisipan untuk berpartisipasi memberikan penilaian terhadap masing-masing poster yang akan ditampilkan. Dan untuk form penilaian poster session itu sudah di-share atau didistribusikan di virtual goodie bag-nya. Terima kasih. Ladies and gentlemen, we are now holding a poster session. For this session, we are gonna present each poster with the duration of time about 6 minutes. So I would like to invite all the participants to enter the room, the meeting room, so that everyone can assess or can see the poster. And don't forget that we would like to ask your willingness to give assessment or to rate each poster. And for the assessment form, it's already shared in your virtual goodie bag. Thank you. Bapak Ibu partisipan, kami mohon kesediaannya untuk memasuki ruangan karena sebentar lagi kami akan menampilkan poster. Dan masing-masing poster akan ditampilkan selama 6 menit. Dan kami juga memohon kesediaan Bapak Ibu partisipan untuk memberikan penilaian untuk masing-masing poster. Adapun form penilaian sudah kami sediakan dan sudah didistribusikan melalui virtual goodie bag yang sudah diberikan oleh panitia. Terima kasih. Ladies and gentlemen, we are now presenting the first poster. So again, I would like to ask your willingness to give assessment for the poster, and the form is provided in your virtual goodie bag. Thank you. Bagi Bapak-Bapak, Ibu, seluruh partisipan yang mungkin mengalami kesulitan melihat poster yang disajikan di layar, kami persilahkan untuk maju ke depan jika ingin melihat lebih dekat dan lebih mudah untuk menilai. Jadi kami persilahkan sekali lagi untuk maju ke depan mendekati layar agar dapat melihat atau membaca poster dengan lebih jelas. Terima kasih. Ya, untuk lebih jelas juga para peserta dapat melihat poster tersebut langsung di Zoom meeting ya, karena tampilannya akan lebih jelas. Well, ladies and gentlemen, now we are presenting the second poster. And again, I would like to remind you all to give the assessment for this poster using the link provided in your virtual goodie bag. Thank you. Bapak Ibu para partisipan, saat ini kami menayangkan poster kedua. Dan sekali lagi kami mohon kesediaan Bapak Ibu untuk memberikan penilaian untuk poster ini dengan menggunakan link yang sudah didistribusikan di virtual goodie bag Anda. Terima kasih. Ladies and gentlemen, we are now presenting the third poster. So please pay attention and also don't forget to give your assessment for this poster through the link provided in your virtual goodie bag. Thank you. Bapak Ibu para partisipan, berikut kami tampilkan poster yang ketiga. Dan untuk itu kami mohon kembali kesediaan Bapak Ibu partisipan untuk memberikan penilaian melalui link yang sudah didistribusikan lewat virtual goodie bag Anda. Terima kasih. To all participants, we are now presenting the fourth poster for today's session. So please take a look at the poster and also don't forget to give your assessment for this poster. Thank you. Bapak Ibu, saat ini kami sedang menayangkan poster keempat untuk sesi ini dan kembali kami ingatkan untuk mengisi form penilaian yang sudah disediakan oleh panitia pada virtual goodie bag Anda. Terima kasih. Okay, dear participant, now we are presenting the fifth poster. So please take a look at the poster and also don't forget to give the assessment through the link provided in your goodie bag. Thank you. Dear participants, now we are presenting the sixth poster. Okay, seventh. We are now presenting the seventh poster for this session. So please take a chance to give the assessment for this poster through the link that has been provided in your virtual goodie bags. Thank you. Ladies and gentlemen, we are now presenting the 8th poster for this session. So please take a look at the poster and also don't forget to give your assessment for this poster. Thank you. Dear all participants, we are now presenting the ninth poster for today's session. So please have a chance to give the assessment for this poster. Thank you. Dear participant, now we are presenting the last poster. So don't forget to give the assessment for this poster. Thank you. Ladies and gentlemen, we have finally come to the end of this program meeting. So before we leave this room, I would like to remind you that the panel session will be held tomorrow morning, started at 9 a.m. So don't forget that. And also, I'd like to inform you that there is a change in the room that you're going to attend tomorrow, which is for those of you who attend the offline meeting, the room will be Bayan room. Okay. And then for those of you who attend the virtual meeting, we have Malimbu merese, and tembolak room. Sekali lagi, saya ingin mengingatkan kepada para partisipan bahwa panel session akan kami laksanakan besok pagi dimulai pukul 9 dan sedikit perubahan terkait dengan room untuk bayan room. Sekali lagi, untuk bayan room, presenter yang akan menyajikan artikelnya yaitu yang offline. Sedangkan untuk Malimbu, Merese, dan Tembolak, presenter akan hadir secara virtual. Jika ada hal yang ingin ditanyakan terkait dengan teknis pelaksanaan besok, para partisipan dapat menghubungi panitia secara langsung. Dan demikian informasi yang dapat saya sampaikan. Lebih kurangnya mohon maaf dan terima kasih banyak karena telah berpartisipasi dalam kegiatan pada hari ini. Hope you have a great day and Assalamualaikum warahmatullahi wabarakatuh. Mohon maaf ada tambahan informasi.